is the head of Coal and Coke Technology Process Technology Division of Tata Steel, and I'm sure he will add value to today's proceedings. Now, our keynote speaker of today is Mr. V.R. Sharma, Managing Director of JSPL, who will join us a little later because he said he has another meeting. So he will join us around 3:45. I think till then we'll have the inauguration in place. So right now, Ankit, we have 4 minutes to go. It is 3:26 by my watch. So another 4 minutes, we'll get started. And Subrata, anything that you would like to add before we start the inauguration?
Thank you, Nimalu. Good afternoon, Dr. Saito, and whoever has joined already. Good evening, rather, Dr. Saito. During this pandemic, it will tried steel and metallurgy to conduct this one, maybe 23rd, I presume, no? 23rd webinar in last 1 year. So little more than last 1 year. Steel and metallurgy has been trying to assemble all the eminent personalities of iron and steel industry and going ahead. Today's topic, we are eagerly awaiting to hear from eminent personalities, both research, plant operators, because coke being the fossil fuel is in the threshold of the whole world is trying to reduce the use of coke and introduce hydrogen. So this, we hope this will be an interesting session, and we'd like to hear from Dr. Saito and others, Dr. Mukesh Kumar, Mr. Das, Tata Steel, everybody. So let's wait and have a discussion on the most useful input material for iron making.
I'm very happy to hear from Japan, especially so Andy us to this he gave to this opportunity to join to the fantastic meeting. So I'm very glad. But again, I want to the emphasis from at the moment is Japan is that Golden Week is a 2 weeks holidays period. So at this moment I'm a relaxed timing. So and especially a Friday night, especially at the moment in Japan, it's about 7 p.m. So just with the drinking time, but I'm just waiting here. Anyway, so I'm waiting, and I want to discuss with deeply about the coking operation, especially India and Japan. So I want to introduce our Japanese technology with the scope 21. So anyway, so please join us. Thank you very much.
Thank you, Mr. Deshpande. Would you like to add anything before we start our formal inauguration? Deshpande ji, you are muted. Please unmute yourself.
Just want to share with everybody else because I also am currently associated with a Chinese company called ACRE. ACR, Yangshan Coke and Refractory Engineering Company. So they are the, you can say, premier design institutes in China for coke making.
Hello.
Now, because I was earlier in Tata Steel and we got their coke ovens to come to Tata Steel. So I am a little bit close to their senior management as well. So I happen to be on their board when they have set up a company in India. So that is primarily to sort of give you a little additional introduction of myself at this juncture. But today, of course, I am talking as an individual. I am not representing them. I would like to speak myself. I was going to touch on the environmental management subject today in the coke making area. So, of course, when I get to that subject, I'll talk more about it. But at Tata Steel, we had a significant amount of ups and downs in coke making. Therefore, we have passed through multiple good and bad experiences. We had batteries collapsing, we had new batteries coming up, we had batteries doing phenomenally well, we had stamp charge technology coming in, and we had, let's say, the World Steel Organization coming in and actually praising the coke ovens. There are many things which happened. And I happened to be a witness to many of these ups and downs when I was working in Tata Steel. I worked almost for 25 years in coke making area. So that's a little bit of, let's say, background. And of course, Amitabh Shankar and others in Tata Steel would know a little bit about it. The beauty is that Tata Steel has learned on coke making over the years from Nippon Steel, people in Nippon Steel. We had an ongoing collaboration. We had an ongoing benchmarking arrangement with POSCO. We had our own Tata Steel Europe, where Hugavans and the British Steel firms of the erstwhile companies, they had some eminent people. So we had a privilege of having to work all along. And then in the end, we beautifully integrated the whole operations in terms of raw material sourcing, coke making, quality making, technology solving, etc. So that's the little bit up to the time. Now it's 3:31. We can start normally, or if you have time, we can keep talking a little bit.
Thank you, Deshpandiji. Thank you so much. I'm sure your experience with Tata Steel will add a lot of value to the entire thought process in the coke making technology which Tata Steel undertook. And with that, I think we are on right at, yeah, it's time, 3:32 by my watch. So Ankit, if you could start the proceedings of the day.
Yeah. So good afternoon and a warm welcome to everyone, to all the panelists and attendees who have joined us today, and even everyone watching on our live stream on YouTube. So we welcome you to our 23rd webinar titled Environment Management, Energy Utilization and Economic Operation of Coke Ovens. Warm welcome to our sponsor for this event, Veta Technologies of the SMS Group, and to the chairman of our organizing committee, Mr. Subrata Mitra, ex-joint managing director, Envioronment Co. And I would like to introduce our panelists for today. Is my screen visible to everyone?
Yes, yes.
So we have, for the keynote speaker, we have Mr. V.R. Sharma, Managing Director and CEO, Jindal Steel and Power Limited. Chairman of our organizing committee, Mr. Subrata Mitra, ex-joint managing director, Envioronment Co. Limited, and also the chief editorial advisor of Steel and Metallurgy. Then we have Mr. D.P. Deshpande, ex-managing director, Tata Sponge Iron Limited. Dr. Rana Subhashish Chakraborty, he's the director marketing and director production, additional charge, Heavy Engineering Corporation Limited. So unfortunately,
Ankit,
I got to know today that he has been diagnosed with COVID and he's suffering from high fever. So he won't be able to join us today. We hope he recovers soon. We wish him a speedy recovery. Moving on, we have Mr. Peter Litzio, Director, Schwelgen Coking Plant, ThyssenKrupp Steel Europe. Dr. Thiago Tuchetti Maya, CEO of Veta Technologies. And we have Dr. Mukesh Kumar, Director, SRTMI. We have Mr. Ajay Arora, Executive Director, IC Steel Authority of India Limited, Research and Development Center for Iron and Steel. Dr. Koji Saito, Executive Advisor, Research and Development, Nippon Steel Corporation. Dr. Anrin Bhattacharya, CEO, Resairon, Austria. Dr. Amitabh Shankar, Head Coal and Coke Technology, Process Technology, Tata Steel Limited. And Mr. Bidyut Das, Principal Researcher, Coal and Coke Making Research Group, Tata Steel Limited. So thank you all for joining us today, and also thanks to our sponsor for supporting this event. Now, before we proceed, I would just 1 second. Is my screen still shared? Or yeah, sorry about that. Yeah, so before moving on, I would just like to share a few short guidelines for smooth platform management. First, to all the attendees who have joined us on Zoom to listen to our discussion, we have a Q&A section in Zoom which can be accessed by all the panelists and the attendees. I would request everyone to post your questions and queries in the Q&A sections or in the chat, and it will be visible to all the panelists who can choose to either answer it live or directly in the chat. I would also request all the panelists to keep their microphones muted when the other panelists are speaking to avoid any kind of noise feedback. And last but not the least, I would request everyone to adhere to the time limit as given in the program to avoid any delays. So today our session moderator will be my father, Mr. Nirmalya Mukherjee, editor, Steel and Metallurgy. And I would now request Chairman of our organizing committee, Mr. Subrata Mitra, to deliver his welcome address, followed by which we'll have the national anthem and take the session forward.
Thank you, Subrata. Before you proceed, let me welcome Sharma Saab. Namaskar, Sharma Saab.
Namaskar, namaskar, namaskar.
A warm welcome to you. I know it is very difficult time in Delhi that you are going through, but let me congratulate you for the initiative that JSPL and our industry has taken during this, very difficult time, sacrificing even our code requirement for our oxygen in our plants. You have done so much. The industry has done so much, and we were just discussing, Dr. Mukesh Kumar and myself, that we should be proud of what our industry has done during this severe crisis period. And gradually our industry is getting, with the support our industry has given, things are getting back to normal. And I believe in Delhi also yesterday, the supply was okay. And let's hope it normalizes in the next few days. So with that, I would request Mr. Subrata Mitra to deliver the welcome address, followed by the national anthem, and then our keynote speaker, Mr. V.R. Sharma, will be addressing us. So over to you, Subrata.
Thank you, Nirmalu and Ankit. Once again, we have assembled virtually on a very important topic. And good afternoon to panelists in India, good morning to panelists in Europe, and good evening to Dr. Saito in Japan. So the topic of today, coke, is the issue worldwide. Being a fossil fuel, I won't take much time. Everybody knows, all are eminent, knowledgeable, experienced personnel. The world is doing everything to get rid of coke and use other reductants for iron making. Get rid means it's not so simple. Coke will continue to be used for many more years. Otherwise, iron making will stop. So anyway, the topic, main agenda for the topic, environmental management, that's the most important issue of CO2 control, energy utilization, and economic operation of the coke ovens are the very important points that we have selected for today. We have a mix of industry heads today, people like Mr. Sharmaji, coke oven equipment manufacturers like HEC, technology suppliers like Nippon, very senior research personnel from India and Japan, Dr. Mukesh Kumar, Dr. Saito, and coke plant operators. Here I would like to say a little about Tata Steel, because we have ex-Tata Steel, Mr. Deshpande, and two present Tata Steel. According to my information, because of my family connections, Tata Steel is perhaps the only company which owns coke oven mines for more than 100 years in Jamadova area. So Tata Steel has perhaps the most wide experience of handling coking coal, which is a big, I should say, culprit for India, because we don't have coking coal much. We have to import coking coal, and that raises the production cost, and every element goes into the iron and steel cost. So the coke blending with non-coking, we'd like to have some knowledge of the plant operators, including Tata Steel, and with all the eminent panelists, we hope discussion, because the steel industry is still emitting 7 to 9% of CO2, out of which a major contributor is coke. So with this, I would like to throw the floor open for discussions. We're eagerly awaiting to listen from you, all the eminent panelists. Thank you.
Yeah. Thank you very much, Mr. Shubrata Mitra. So moving on, we will now start our national anthem, followed by which we will have the keynote address by Mr. V.R. Sharma. So I would request everyone to please rise for the national anthem. I'm sorry, I'm having some problem with the screen sharing. Just a second. Yeah.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, gentlemen. Ankit, you can go ahead, and may we request Mr. V.R. Sharma to deliver the keynote address. Sharma sir. Yeah, may I request Mr. V.R. Sharma to deliver the keynote address, please. Mr. Sharma? Ankit, can you ask Pradipta to check if Mr. V.R. Sharma can hear us? Or maybe Mr. V.R. Sharma is on a telephone, phone call or something, right?
Yeah, he's in the panel right now, but
Yeah, I can see he's in the panel. But Sharma sir, can you hear us? May I request Mr. V.R. Sharma to Ankit, if you can ask Pradipta to check with Arunesh, TA to Mr. V.R. Sharma if he is free or he has gone somewhere. Just ask Pradipta to check up with Arunesh, to call Arunesh.
yes, I have already. Yeah.
Mr. V.R. Sharma, can you hear us?
Maybe he got caught up with something. Can we, in the meantime, move on to the next speaker and
No,
then?
let's wait for, he's a keynote speaker, so
Yeah.
it is impolite to cross over from the keynote speaker. So let's wait for one more minute. Mr. Sharma, let me send him a WhatsApp message. Mr. V.R. Sharma, Sharma sir, can you hear us?
I think you can give in a fast telephone call to check if he's still there.
Yeah, just let me try that. He disconnected my call. So, oh, his system is down. I think Mr. Jia Sharma's system is down, so somehow we'll have to move to the next speaker before, till such time his system starts working again. So that's the message I got from him. So then we'll move on to our next speaker, which is Dr. Mukesh Kumar. Again, someone who is very close to my heart, more than, a family member, I would say, someone whom I respect a lot. And I have a lot of, things which I've learned from him, and a lot of guidance I always keep taking from him. Like Mr. Subrata Mitra, he's one person from whom I take a lot of guidance from. So over to you, Dr. Mukesh Kumar, who is the director of Steel Research Technology Mission of India. And as I mentioned earlier, it is an initiative of Ministry of Steel, Government of India. And the idea is to develop indigenous technologies. So Dr. Mukesh Kumar Saab, over to you.
Thank you, Nirmala ji. Can you see my this thing presentation, please?
Yes, sir.
Yeah. Good afternoon to everyone, all the panelists as well as the attendees, and thank you, Nirmala ji, for giving me an opportunity to share my views in this important webinar, which is on environment, energy, and economy in Coke Oven operations. Because Coke plays an important role, very, very important role, not only from reducing agent point of view, but from the cost point of view also. When the coal prices was in the range of around $200 to $250, around 40 to 45% cost of iron and steel making were contributed by the coal itself. That's why the coal becomes very, very important. And what you told, that environment, energy, and economy is one of the things which needs attention from all the corners. So in light of that thing, the present webinar will be very, very important, because most of the technology suppliers are here. So I thought not to focus much on the technology aspect, but just to give a brief about where we are in India today, what we are looking for, and where we have plans to go. So on those three aspects, so that either the technology suppliers or the new plant manufacturers, they can look into it, the opportunities, whatever is available in India. So if you see, India is the second largest producer of steel, and we are producing around 102 million ton of steel, whereas we have a capacity of around 142 million ton. Out of 142 million ton, around 90 million ton is located in the integrated steel plant. And when we look into the integrated steel plant, people are using Corex technology, EAF and EOF. So around 70 million ton capacity is produced by blast furnace route. So that's why around 55 to 60 million ton of coking coal we are requiring every year, and 90% of which is coming by import only. Our consumption is one of the lowest. Right now it is around 74.6 kg against world average of around 225 kg. We have planned to increase our consumption from 74 kg to around 158 kg by 2030, and that will require a production capacity of around 300 million ton. It means a lot of opportunity is there for the industry to grow. Looking into the consumption trend, what is going on for the last few years, we are getting a CAGR of around 6 to 7%, except in 2020. Because of this pandemic, the demand was low. But from 2020 onwards, our demand was picked up and it was much more than what it was there in 2019. Again, this pandemic has come, maybe for few months, demand may be affected, but we are very sure with this 2021, we will get a growth of around 11 to 12%. Looking into large opportunity into the steel sector, our major players in this industry have already announced various expansion. That may be a greenfield expansion and there some may be brownfield expansion. Like SAIL is having a 2025 vision in which they want to increase capacity from 20 to 50 million ton in two phases. By 2025, they want to increase to 35 million ton and then 50 million ton by 2030. Similarly, Tata Steel has announced expansion at Angul, Kalinganagar and Jamshedpur, so that increase the capacity from 20 to 40 million. Like ArcelorMittal, they have announced a greenfield project in Odisha of 12 million ton capacity, and at the same time, they are increasing capacity of their Hajira plant from 10 million ton to around 18 million ton. Those
Ankit, Mukesh Kumar, just a second. Ankit, can you mute everyone? There is a lot of feedback coming in. If you can mute everyone, please.
Yeah, actually, the feedback is coming from Mukesh uncle's microphone. So I guess it is.
Now it is okay. Now it is okay.
Yeah, but,
Mukesh, yeah.
But no, but he has to unmute and speak. I think that is where the feedback is coming from.
Yeah. Dr. Mukesh, please go ahead. Let's see.
Mukesh uncle, you are muted.
You have to unmute.
Just click on unmute. Yeah.
Similarly, JSW is there. They also have big plans. They also have planned to put up a 13.2 million ton smelter, steel greenfield plant. Plus, they want to increase their through this thing also. Some greenfield project like in Andhra Pradesh is coming. So it means total around 117 million ton of capacity is expected to come in the integrated steel sector, where coke is going to play a major role. But where we will get the coal? Today, our 80 to 90% of the coal requirement is met by import, but we have large amount of the coal available in the country. If we look, prime coking coal around 5.3 billion ton, medium coking coal around 27 billion ton, semi coking coal around 1.7 billion ton. So lot of coking coal is available, but unfortunately we are not in a position to use it because of the technological constraints. Most of the plants, whatever technology they are having, that is not suitable to blend this type of coal there. Government of India has made an extensive plan that by 2025 they want to increase the coking coal capacity to around 75 million ton per year. If we, as they are presuming, with vast coal to bring down the ash to around 18%, they will be getting around 20 to 25 million ton of coal annually. So we have to see what technology in future we should select so that our maximization of Indian coal can be achieved through their place. So if we see the coke oven, today's what options we are having, most of the plant in SAIL and RNL, they are fitted with top charge system. Those are having wet quenching, which is generating large amount of toxic cyanide effluents. So we want to get rid away with this thing because this is one of the most important environmental constraint is there. Second thing, what we find is there is a limitation of blending Indian coal with this type of system. So that is another risk. That's why some of the plant like Tata, JSW, JSPL, they have installed stamp charge battery with recovery type, and some people have adopted dry quenching also. If you presume that these coke ovens may last only maximum around 25 years or maximum 28 years or 27 years, although in China, life they are getting around 15 years or 18 years. So most of the coke ovens which have been built in SAIL and other plant are quite old and they will require either replacement or refurbishment. So a lot of opportunity will come in addition to new projects in existing plant also. Lot of coke oven projects are going to come. With dry quenching, whatever people have adopted, they are looking into opportunity for generating power also. And around 10 to 15 million ton megawatt per million ton of coal we can generate additional power. This can minimize our energy reduction also drastically. At the same time, it can help in reducing my greenhouse gas emission to the tune of around 0.1 million ton per million ton of coal every year. So this today, our greenhouse gas emissions is very high. It is varying between 2.2 to 2.8, and we have a target to reduce it. So I think this is one of the area which will help in doing this thing. Then once we get this type of coal, we will get some good productivity in blast furnace also, because it has been seen that 5 to 10% consumption can be reduced in blast furnace. Then higher compaction in stamp charging will help in using our Indian coal as well as in utilizing petroleum coke, because we are also producing a large amount of petroleum coke, which is not possible to use in top charge system because of this thing. So then in future, lot of other technologies are coming. Although lot of effort have been made on a continuous coke making plant, like CTC, Coal Technology Corporation USA, they have developed a process, but that could not be commercialized. Then Caledron process is there in USA. They have also developed a continuous coke making process, but that also could not be taken to the commerciality. Similarly, Ukraine, they have developed a process called UK HIN process. That also, it was pilot level, it was tested, but it could not be taken in the commercial scale. Now we have hope on scope 21. We feel if scope 21 comes, then it may resolve number of issues. So what we presume that today, although some people are advocating for heat recovery and non-recovery type of coke oven, but we feel stamp charge with recovery oven and with CDQ may be the technology of the choice in future to come, sir. Another things which will come will be the height of the coke ovens. What type of coke ovens we should have, whether it is 4.3 meters, 6 meter or 7.6 meter, which are called as jumbo reactor also. So if you look into a comparative analysis of 4.3 and 7.6 meter, for a 2 million ton plant, we find where we require 5 batteries of 4.3 meter, in 7.6 it is only 2 batteries. Similarly, number of ovens has reduced from 325 to 140. Number of pushes per day, which is very important for our environment and other thing, is greatly reduced from 520 to 135. Similarly, the space requirement, today we are fighting against land requirement. So land requirement also is reduced drastically. So we feel, looking into the merits of jumbo ovens as well as 6.25 meter and 6 meter ovens, we feel that in future 6 to 7 meter high coke ovens may be the technology of choice in future. So this is what we feel when we are looking for future options. This may be one of the people will be looking for these type of systems. Now, as I told, continuous coke making, because Dr. Koji Saito is there, he will be making a detailed presentation on this thing. I was not aware, so I thought just I will highlight some of the points. It's already in operation since 2008. So Dr. Saito may be in a position to explain why this technology could not be taken up in a commercial world, but it seems that now it is available for the commercial use. If it is available for a commercial use, I think this will change the entire scenario, because this will give a high quality coke with more than 50% like Indian semi-coking coal and middle coking coal can be utilized. It will save energy to the tune of around 21%. So biggest achievement will come in terms of the emission reduction, because for a 1 million ton plant, they are claiming it will reduce around 0.4 million ton per year of emission. It will reduce. Similarly, operating cost is very low and production capital cost also is very low. So detailed presentation on this thing will be given by Dr. Koji Saito. So I will not take much time on this thing. Just I will show a photograph of what is the configuration, and I hope in detail Dr. Koji Saito will explain on this thing. Coke will remain one of the most important thing unless some alternative technology which are non-coking coal based comes into operation. Otherwise, coke oven focus will be there. Like in alternative technology, Russian people are talking about the magma technology, in which they are saying they want to use non-coking coal, and they want to convert limestone also. It is a limestone into lime, also on lime. Then recovering of the oil based. This technology is using sodium cooling as a coolant, and I hope if this type of technology and most of our Indian coal can be utilized, and our dependency on imported coking coal can be reduced drastically. But ultimate our objection is CO2 reduction, as you have mentioned also, because today some of the plant is operating even at 2.9, 3.1, and we right now we have set a target of around 1.8 for ourselves. But 1.8 also is looking very, very big. So once coke oven is contributing around 40% in greenhouse gas emissions. So whatever technology, new technology we select in the coke oven, that will have a bigger role to play in meeting our requirement of around 1.8, what we have targeted. Although some of the technology countries, advanced countries like Japan and other things, they have already reduced even below 1.8 also. And this may be a right direction. So what topic you have selected, that is energy, economy, and environment. That is the root. And whenever we are selecting new technology, we have to bring focus on all those things. Thank you very much. We hope with the participation from the because a lot of technology suppliers are there. Whatever input they will be giving, that will be very, very important for all the Indian industry to decide about the future roadmap for new plant as well as for replacement. Thank you very much.
Thank you so much, Dr. Mukesh Kumar. Dr. Mukesh Kumar, thank you so much. Yeah. Unfortunately, we had some issues with the audio feedback. Otherwise, it was an excellent presentation. I hope people must have been able to hear what Dr. Mukesh Kumar had said and see the presentation. But somewhere there was a feedback in the noise, with the noise which was perhaps a little worrisome. Other than that, it was thank you so much for the study you have done on the coking coal technology and the target for reducing our CO2 footprint, as well as the efforts to see what is the best possible option for recovery or non-recovery type performance. So thank you, Dr. Mukesh Kumar. Is Mr. V. S. Sharma back right now?
No, he's
Where
not.
is he?
He's not in the panel at the moment.
Okay, we'll have to wait for him until such time. We'll move on to our next speaker, which is Dr. Koji Saito from Nippon Steel. Dr. Koji Saito, a warm welcome to you once again. And I know it is quite late in Japan right now, but and you're on holiday season. In spite of that, thank you so much for joining us. And it is over to you. And Dr. Mukesh Kumar also mentioned about your presentation, and we are eagerly waiting to hear from you. Over to you, Dr. Koji Saito. I request everyone to keep themselves muted so that there is minimum feedback.
Hello, this is Koji Saito from Nippon Steel. Can you see my slide?
Yes, we can see the slide. We can hear you.
Okay. Thank you for your opportunity to present my topics about the Scope 21. So Scope 21 stands for the super coke oven for the productivity and environment enhancement total to 21. So that is an important thing. That is a coking coal price transition. So as you know, up and down, up and down, up and down, up and down. Always we are trouble that. So especially Australian cyclone, and sometimes China, sometimes China also. So that is a very important thing for us, especially in Japan. So, and also next futures, that important things, that's the coking coal, supply and demand. As you know, this is suspended, possible, probably, highly probably also. But that is important demand basis. But as you know, so demand is expected to cover the production from the existing coal mine until 2025. That is a very important thing for the Japanese steel industries. So we have to recover so the another resources that's important. So of course, coking coal is a very important thing, but we think we have to look for the another resources. For example, the slightly coking coal or non-slightly coking coals also. So, and also we have another problem. That the problem is the conventional coking process. So, but also you can easily understand. So with the in coking coal is the resources only limitation about only 10% like that. But we look for the another resources for with the Roland coal and another one. So, and also again the coking price is a coking coal price is also very another important. In Japan, we developing the new another technique. For example, the CMC. It means the coal moisture control, and also a DAPS. For example, the dry cleaned and agglomerated propulsion system also. But that's the only limitation about the sharing of the coking coal ratio. And that is for the result. Of course, we control to the moistures about the coking coal. So it means that we control the moistures. So it means you can see that moisture is decreasing. It means that we are increasing of the bulk densities like that. It means we can utilize of the non or slightly caking coal ratio about from the 10% to the 20 or 40% like that. But only we have some limitation like that. So we need to the another new technologies. And also we have another problem. That problem is the life of coking oven in Japan. So we construct the about 40 or 50 years ago about the coke oven. So it means their lifetime is also limited. So it means the estimated demand and supply of the coke demand in Japan also. So in near future, we have to be the shortage of the coke oven. So it is also another important thing. So we developed new coke oven technology. We call the scope 21 like that. The key technologies is a rapid preheating system like that. It's a preheating heating system before the coking chambers like that. And also they have some another environment issue also. So this is a basic idea about the preheating scope 21 like that. Maybe you can easily understand. This is rapid heating preheating. This is a conventional process like that. So of course you can easily understand. So the temperature is about 100 centigrade like that. Basically about 5 and 6 and 8 hours like that. And also gradually increasing the temperature. But on the other hand, in the case of 2021, so we introduced the carbonized preheating system like that, and then it means we give the shortage of the process timing. So that is very important thing. So again, I want to emphasize that the rapid preheating is a very important thing. So our colleagues here get a very, very fantastic result of the investigation of the improvement of the coke strength like that. When some, maybe you can see this very rapid heating system treatment. So their drum index is increasing that. But on the other hand, low preheating system. Also, of course, drum index decreases that. So that is a key technology. Is again that's the preheating, especially a rapid heating system for the improvement of the drum index. So what is the mechanism with the rapid heating cores? Just a scope. As I will skip to the in detail example. But anyway, so this is a local and this is rapid heating system. But when we use to the rapid heating system, so in the case of the core structures, especially relaxation of the rapid structure, is a dramatically changeable like that. It means we can get of the core strength is higher at the same condition. That's a fantastic technique like that. So, and also we can, so using to the some molecular simulation for the heat freezing like that, you can easily understand this is a rigid structure of the low core. But when we try to the relaxation of the rigid structure for the rapid heating system, so maybe you can see some molecule is released from the rigid structure by the rapid heat treatment like that. So that is a fantastic result from the molecular simulations. Oh, so we decided to the scope 21 development schedule, basic research, and there's a bench scale test and pilot scale test in the for OITER. Already your colleagues are mentioned. And this is some cold treatment and cold oven like that. We step up some scale up technologies. First is a bench plant, 0.6 ton per hour. The next is a 60 ton per hour. And finally, we decided the 240 ton per hour like that. And then we can set up these kind of the pilot plant in Nagoya Steelworks. And then we move to the commercial scale plant like that, and about 10 years ago like that. And then we set up like the coke oven in the OITA battery like that. And as a cooking tab, about dramatically about only 13 hours. And also working ratio is about 200% like that. And also NOx is also decreasing like that. And then this is an external view of the OITA number 5 coke oven. And then that's a fantastic result about the operation result in OITA works. You know, so basically in Japan, we need to the high drum index over the 8.4, but we got is the 8.6 drum index. And also at the moment, we use to the utilization of the rate of the low run core over the 50% like that. And then we decide to the next step in the Nagoya new coke oven using to the rapid heating system in the scope 21. And then we decided like that. And of course, we need the foundation work and also the environment issue also. And then we constructed like these capacities. The productivity also 1.7 times. And also our target is a semi-soft coking core over the 50%. And also CO2 emission is like that. And then what the result like that? This is the working ratio. Again, we set up the plan to the like this ratio, but you can easily understand that our result is a much more over that. And also, this is an incredible data is operation result. This is a known or slightly caking coal blend ratio. Maybe you can easily understand. Our target is a 50%, but we establish as over 60 or nearly 70%. It's a remarkable result of that. And also, this is the operation status of this drum index. Our target is 85 because in Japan, blast furnace is a very big one, over the 5,000 cubic meters. But we get it is over the 85 of the drum index operation ratio. Of course, again, using to the over the 50% of the non or slightly caking coal blend ratio. So that's the remarkable result of that. And this is the conclusion. We got it already, Oita number 5 rep, and also we constructed Nagoya number 5 also. And the coking time about only 13 hours was attained to the charging preheating high temperatures. And also high strength coke would be produced both over the 60 mass or non or slightly caking coal blend ratio. And the important things is the mechanism, is the in situ NMR imaging technique, which is developed and organized. And in our company, clarified of the mechanism of the rapid preheating. That this is the important things, is the mechanism is a very important thing. So we can decide to the next step. It means we constructed the operations, or we constructed the new process in real steel works. Okay, so SCOMP 21 is a core effective use resources of global warming with significant contribution to the solution of the problem. It is expected to go to play major role with the refracting device in relation to international competitiveness. And 2013, we got it, Okochi Prize. That's the very, very memorized in Japanese memorized tours. I'm very lucky, so I'm get some memorized here. And it is a great example, successfully able to achieve to an actual reduction in the industry and university cooperation and national project, because SCOP 21 is a typical and successfully the national project in Japan. Thank you for your attention. Great off. Thank you.
Thank you, Dr. Koji Saito. And 素敵なプレゼンテーションをありがとうございました。And we hope that you will continue to stay and enjoy the upcoming presentations. So moving on to our next speaker. Yeah, we have Mr. Peter Lizio, Director, ThyssenKrupp Steel Europe. So, Mr. Lizio, herzlich willkommen zu unserem Webinar und wir freuen uns auf Ihre Präsentation. Over to you, Mr. Lizio. You are muted, Mr. Lizio.
Can you hear me now?
Yes, we can hear you.
Okay. I tried to share my screen.
Yeah.
And we'll open. I've prepared. Do you see my presentation?
Not yet.
Shit. I had my first session with Zoom because at ThyssenKrupp we are used to use.
You see a green button actually in the bottom, maybe.
Yes, there will be a green button at the bottom. You can click on the green share screen button, and it should show you the open presentation if you have it open already. And then you have to just click on it.
I tried once again. Oh, fuck. Open my presentation. Can you see it now?
No, not yet.
What you can do is you can mail. You can also mail it to my son Ankit, and he will since it's easier if you can mail it to him, and
Can you see it now?
Na, Peter, es gibt eine grüne Pfeile unten.
Ja,
Wenn
ja,
du
ich habe
aufklickst
hier 2 Bildschirme. Bildschirm 1,
und
Bildschirm
dann-
2.
und dann
Ja.
Präsentation freimachen.
Verdammte Scheiße.
Du musst vorher die Präsentation offen haben.
Ja, die habe ich offen.
Und jetzt einmal unter die grüne Pfeile, dann siehst du einige Optionen.
Jetzt gebe ich Bildschirm 1 frei.
Jo.
That's
That's-
coming.
It's coming? Ah, that's fine. Okay, gentlemen, please, it was a technical problem. Okay, now, very short, the situation in Germany. In Germany, we are operating 5 coke plants, not comparable to your Indian conditions, with a total production of around 10 million tons a year. They are connected to our steel plants. My plant at ThyssenKrupp site is a part of an integrated steel plant. I'm operating the new Schwelger plant established in 2003 with a total production of 2.8 million tons. And I'm supplying 4 blast furnaces at TKS. We're running also 2 steel shops at TKS. And that's an overview about our blast furnaces. We have 2 big ones. Our biggest one, number 1, with a half diameter of 14.9 meters. I think it's number 6 or 8 in the world ranking list of the biggest blast furnace. It was established in 2093. Blast furnace number 1, who will get a relining in July this year with a half diameter of 13.6 meter. Blast furnace number 9, an old one, with a half diameter of 10-12 meters, and oven number 8 with a half diameter of 10.7 meter, installed in 2012, I guess. Something special is this: both blast furnaces are running with 1 pit. They have only 1 pit, one hole. Total capacity of ThyssenKrupp steel in Duisburg is 33,000 tons with these 4 blast furnaces, and they supply once again 2 steel shops. Short information about my plant. This is an overview of my plant. It is the biggest coke oven in the world with a length of 28 meters. That means usable 20 meters with a height of 8.43 meters. Typical overall width of 590 millimeter and operated with 1,330 degrees Celsius. The effective volume is 93 cubics. That depends on my bulk density, with about 79 to 80 ton of coal per charge. So I have a high production ratio. Normally we have a coking time of 24.5 hours with our 140 ovens. And we are doing normally about 133 pushings a day. Something I'm really proud on is the fact that we are running the plant with about 321 guys. That's world record. If you see the productivities, the tons per man, we are operating with only 8 engineers for the entire plant. And it's shown here underneath. The coke plant starts in 2003 and was 100% bank owned. It was not an asset of ThyssenKrupp. So I was doing the job as general manager for the banks, and my only customer was ThyssenKrupp. My production of my coke oven plant was 68% of the demand of ThyssenKrupp blast furnace department. Nowadays, we have done a takeover. In 2019, ThyssenKrupp bought the total asset from the banks. So nowadays, I'm a ThyssenKrupp guy working for ThyssenKrupp, and I'm a member of the blast furnace department of ThyssenKrupp and responsible for coke making in my plant. So that's the overall story. And this coke oven plant with a total throughput of coal of 10,600 tons a day. You see this number here. this is the maximum allowed throughput from a plant, was displacing the old coke oven plant of ThyssenKrupp. The old plant was starting in 1895 and was shut down in 2003 when we started with the new Udi plant. So we have more than 100 years of experience in coke making at this site. So when I talk to foreign people, special things, when I talk about a coke plant, for me, a coke plant is a gas transformator. I'm buying the cheap mixed gas from the mill. This is a mixture of BF gas and the recovered steel chop gas from the mill. And I'm selling the coke oven gas with a high calorific value. So for me, a coke oven plant is a gas transformator. Low caloric, high caloric. Let's have a look into the chemistry of the gases. When I take over the gas from ThyssenKrupp, I take the BF gas with 50% of nitrogen, that's shit. And I take over 25% in carbon dioxide, that's much more shit. And only a quarter of this gas, if you look at 24% carbon monoxide and about 1% of hydrogen, is combustible, giving you energy. The rest is shit. I take over the steel chop gas, much more better, with a higher content of carbon monoxide, two-thirds, 65%, but also 15% of carbon dioxide and 50% of nitrogen. That means also 30% of shit. So when we look at my product, my coke oven gas, you have the high caloric value, you have a very small content of nitrogen, but you have this 63% of hydrogen. And in standby, you have 21% of carbon, of methane. So a lot of hydrogen and a lot of future dreams in Germany are gathering around hydrogen. I go back to a slide, show you some typical ideas of ThyssenKrupp in the moment. Actually, the guys on the other side are blasting in a test sequence, pure hydrogen in blast furnace number 9 to displace pulverized coal injection. So that is one way they are trying, and where they are in cooperation with the politics in Germany. Because in Germany, steel production must get more and more green. That's a political issue. It depends on the European Party. They give you limits of carbon dioxide emissions. I think we have same conditions in Japan, in China. They're thinking the same way. Korea, everywhere, we want to reduce carbon dioxide emissions. In the next step, we think we can utilize this blast furnace for several years with a total impact of hydrogen, and then we want to displace this blast furnace and install a DRI, direct reducing plant, during the next 3 or 4 years. That's a master plan of ThyssenKrupp at the moment. But I'm stay on the conventional side. I'm producing my coke, and this fucking coke will produce carbon dioxide. So we are on the bad side of life. And we are also on the bad side of life because of this molecules, polycyclic aromatic hydrocarbons. Mr. Sato told you about the old conditions in Japan, all batteries. All batteries, that means you have a lot of emissions. Emissions, consider of hydrogen, consider of PAH, especially the 5-ring systems. We call it, this is a number of 16 of this PAH, and the most important, because of its very, very high cancerogenic character, is the benzoapyrene. And in German, we have strict regulations. At the fence of a plant, you must have emissions. That means on the urban side of a maximum 1 nanogram of this molecule in the ambient air. Otherwise, your plant has to be shut down. At the old plant, we're at a distance of 200 meters to the next windows. Government installed a measuring container in 1996, measured the ambient air, and found out 40, 50 nanogram of this fucking molecule. And following, I had to shut down 1 million ton of production on the old site. So it's a very, very sensitive situation in Germany if you have diffuse emissions from your coke plant, and when these emissions are going to the urban side, creating emission. On the other side, we have a lot of struggle and discussion with the authorities in Germany that the workers who are working on the oven top have strained by these molecules. And there is a lot of regulation how to protect the workers from this cancerogenic molecules. Nowadays, we have new regulations. The maximum overall allowed concentration of benzoapyrene in the ambient air of the worker's train, is a maximum 700 nanogram per cubic, and then you are going to the red line. And the target must be 70 nanogram. The future target in Germany is 7 nanogram. And remember, some years ago, on the other side of the street, in the urban area, we had concentrations of up to 40 and 50. But on the over top, at the source of the emission, it's no more allowed to have more than 7 or 70. That's cruel. Cancer disease. If a hunter is shooting a rabbit from the left side and he's failed, nothing happens. If he's shooting from the right side at the rabbit and he fails, then the rabbit is, on a statistical way, dead. In real time, the rabbit survives, but that's statistical. So prognosis about cancer risk are very discussable. But we have this new limit here in Germany, 700 to 70, so we must have to be above 70. And the benzoapyrene molecules are incorporated by the breath, by the dermatologic, by your skin, because it's very easy to go into your skin if you have a fatty skin. And of course, if you eat at the battery, you eat the poison. So you have 3 ways of incorporation. Measuring is normally done by the lung, because when we have measurements by authorities, my workers are very samplers, and the samplers get active char, and in the lab they look how much was the concentration of benzoapyrene in the air. In former time, we had the allowance of 5,000 nanogram max on the battery. Nowadays, 70, as I told you before. But when we sample here at the pulmonetic system, we don't know how much is the transfer rate by the skin and how much is transferred on the oral way. So how can we measure the overall incorporation in the body of a worker? And the possibility is to make a urine biomonitoring. So in Germany, we are forced to do biomonitoring on PAH metabolites. Once again, that are historical numbers from my old plant shut down in 2003. We had 6 battery operated here at the street. Here's the street. And there was the measuring container, and here are the houses. That was the old condition. So the blue ones are the concentration of benzoapyrene in nanogram. You see us swapping off to up to 140, 30, 50, so very high values, and we had to shut down several battery. And in 2003, we shut down the entire plant and started with a new plant in an area about here. That are some numbers measured at my battery and measured at the old battery. When we're looking at the old plant, August Thyssen, numbers from 1995, 94, 95, and take care, these numbers are in microgram. 1 microgram is 1,000 nanogram. So this value stands for 13,400 nanogram for an oven top worker. It's something which looks real if you're operating your own battery. I guess that are values you easily found in Japan on the battery top. As well, 3,800, 6,200. Nowadays, when I measure directly at the machine, close to the charging tube, I'm measuring about 650 at my charging car. So 650 is below 700, but it's not 70. And by German law, I'm forced to think about things to reduce the stress of my worker. Otherwise, they shut down my plant. So we have done a big measurement of all German coke plants several years ago. We measured the stress by air, the conventional measurement in all plants, and you see a lot of high numbers. There are no indications about which plant is measured here. It's encrypted. Also, the concentrations of metabolites measured as 1-hydroxypyrene in the urine. But the 1-hydroxypyrene is an overall indicator of all 16 molecules of the group of polycyclic aromatic hydrogen you have incorporated. It's not directly monitoring the benzoylpyrene. That's the tricky part. So what have we done in our plant? We tried to decrease the inputs on the pulmonary way, on the dermal way, on the oral way. So we take all technical thinkable things to reduce the stress of our workers. We have done a lot of organizational measures with job rotation and shift-wise cleaning. So all the locker rooms, the shower rooms, each room where workers are coming together is cleaned shift-wise, not daily shift-wise. They got clothes each day. My workers get completely new clothes, undertrousers, socks. So that's a contaminated wearing. The jacket is not used at the next day. Each time, completely fresh, washed things. On top, we have this special helmet system. Several companies are producing this protection systems. We have chosen the Scandinavian way of Sundström. You can also buy 3M or other customers. You have a motor and a filter system, and you're filtering the ambient air about PM3, so very fine filters, then of charcoal, and then the cleaned air is blowing under the helmet. You get about 200 liters per minute. And if you're doing heavy work, you need about 60. So you have 140 liters on plus, and it's coming out. So you have always clean air. And under such a helmet, you have a concentration going down to 0. So also choosing and changing the clothes here, it's our way. Something about the problematic with all the molecules and their different boiling points. So 1-hydroxypyrene is not 100% indicating the concentration of benzoylpyrene, which was about you and the ambient air. That is the crux at this one. That is our system. That is our central locker room. Here's my office. When the guys are coming from the parking area with their street wearing, then they go in, leave their white colored clothes on this side, then they go through the wet zone, then they take their new working clothes, then they go out. Then we have a takeover station where they take the new freshly cleaned helmets, then they go onto the works, and when they leave after 8 hours, they come back to this shut, they display the used helmets, which get cleaned in a cleaning station between 24 hours. And then they go back on the black side of the shower rooms, they undress themselves, they leave all their clothes, which get exported for cleaning. Then they get to the shower, and then they come to the clean zone, and then they dress themselves with their street clothes and go home. This is a German standard. Otherwise, it's not possible to produce coke in Germany. Okay, one look into the locker rooms. you have a lot. Everybody has five sets of jackets and trousers and socks and so on, and he's throwing up the used parts here after each shift. Thinking about oral contamination, all my guys got new kitchens to prepare their food in clean atmosphere. These kitchens are cleaned each shift, so everything is clean. There is no dust from the battery because the dust is bringing the poison into the body. Cleaning stations everywhere with special soaps so that they have absolutely clean conditions for living. So coming to a conclusion, this is our target, 70 nanogram per cubic in the ambient air. It's not possible. Also on my relatively new battery. 7 is a target. So you will need the helmet, but you have also take care on the other ways of incorporation. That means the skin, and that means the orals. I told you once hydroxypyrene is not a very good indicator correlating by 100% with the benzoapyrene incorporation in the time before. Nowadays, our German researchers have found a new measurement standard, and now they are able to measure a metabolite, which is called 4-hydroxybenzoapyrene. And he is indicating by 100% the total BAP incorporation during the shift. And this is a big measuring campaign in autumn this year, when all 5 German coke plants have to do an overall measurement, the strain by air, but protected by a helmet, and the overall incorporation lined out and measured by urine monitoring with this special parameter for hydroxybenzoapyrene, but also with the old value of 1-hydroxypyrene to find a linkage between 4-hydroxy, the new parameter, and the 1-hydroxypyrene in formaldehyde. So thank you very much for your audience. Thank you.
Ankit, over to you.
Yeah. So thank you very much, Mr. Lizio. That was a really nice presentation. And our next speaker is Dr.
Ankit, just a second.
Yeah.
There are a few questions in the Q&A section. If you could just read it out for Mr. Saito. I think it is for Mr. Saito.
Yes, Mr. Saito, are you there?
Okay, you can just read out the questions in case anyone else.
I think he is away right now.
Okay, but I can see him on the screen. Maybe.
Yeah.
Dr. Saito, can you hear us? Dr. Saito, can you hear us?
He's muted, I guess.
Yeah, he's muted, but he should be able to hear us. Dr. Koi Saito, can you hear us? Dr. Saito, are you there? Okay. Ankit, you can go ahead.
I will just write a short message to Dr. Saito to reply to the questions when he
the Q&A section.
Yeah.
So you can thank Mr. Peter Lizio for, but it makes us think and wonder, had India been in a situation like this, would you have been able to really produce coke at the end of the day? Neither can we afford it, nor do we have the loss of the value of human life.
Yeah,
is not that expensive in India.
But it's not a good decision.
maybe a couple of €100 is what you pay when you run over someone with your car. A fine of couple of €100. Okay. So that's the value of human life in India, unfortunately.
My goodness.
And I think Dr. Maya would agree that it's not quite different in Brazil. Dr. Tiago Maya?
I think we all have stricter and stricter regulations all the time. But that is a trend that I hope is worldwide. Maybe some places quicker than others, but it is a trend nonetheless.
I stayed in total, I guess, 14 or 18 weeks in Brazil in our former CSA, where the ThyssenKrupp was installing a steel shop in South America, in Brazil, close to Rio de Janeiro. And I stayed there very often because they installed a heat recovery plant designed by the Shaanxi Chemical Design Institute. And there was a lot of problem with the plant. So I become more and more an expert for heat recovery technology together with the Ude guys. But under the license of ThyssenKrupp, safety was a big issue. Also occupational health. So for me, I'm a good friend of lots of my workers, my foremen, and my engineers, and I want that when they got retired, I will get retired in 3 years, that they get retired without cancer. Because of my old plant, I lost a lot of colleagues by cancer. And that cannot be the future for coke making. It's my personal view of this item.
By the way, Dr. Tiago Maia, what is the time in Brazil? Is it very early in the morning, or what time is it?
No, it's 20 past 8. So
it's comfortable.
Yeah.
It is. It's just the beginning of the morning. It's quite comfortable.
So we have from Brazil to Japan, the entire time zones covered the time when we speak. So from early morning to late in the evening.
Normally, under normal condition, I stay 3 to 4 times in China. I'm a member of the Chinese Coke Making Society. I guess I'm the only Western style guy who's member there. And I'm a consultant for the Chinese coke making industry and for the governmental. I give governmental and advisors, and I'm a member of the party who is describing the new Chinese standard of technology. They're starting a new 5-year plan. I want to have impact about the best available techniques, and I'm a member of this team. And also in China, also a special way on human life, but occupational health become more and more an important item in China, and they invest more and more money in this item. And it's a good decision. It's a good way.
Yeah, right. I think globally things are changing. So China cannot hide anything and everything they want to under their wraps. And of course, India being the largest democracy in the world, anything and everything that you do is monitored by the world.
Yeah.
So you cannot do away with anything without being watched. And the attitude is also changing. The approach towards life is becoming more and more valuable across the world.
Yeah.
So this is a positive change which is happening. At one time, we used to blame the Russians. I remember asking Lakshmi Mittal once, "Your people are dying in Kazakhstan." He got very wild with me. It was in a press conference that I asked him, "Your people are dying in Kazakhstan." So then there was their CSR head who came up to me and said, "These people, they have been used to this style of working for donkey's years. So when you give them advice, the first thing they'll say is, 'This is what we have been doing for years, and nothing will happen to us.'" So that was the attitude which was there at that point of time. Anyway, let's hope the world.
I stayed sometimes in Russia making an inspection at Magnesitorsk and Sevastopol, and had a lot of visits by the Russians because they want to catch our technology, but they had not the money to pay for it. But if you see the working conditions in Russia, it's crazy, absolutely crazy. And real work is always done by women, not by the guys, because they are drunk. That's my impression from Russia.
So, Pratoda, I see you with a grim face. Do you have anything contrary to what I said to add?
No, you have revealed some truth, which some truth. So it's we are being attacked by invisible enemy, which you cannot control by the wonderful presentation which you gave by gadgets. The nature has act. So you people have become very clever. So and so the world is fumbling what to do with the virus.
Yeah.
Yeah.
So anyway,
So
we'll come up.
all the more reason for us to have maximum protection available for
Yeah.
our employees and
Yeah.
the people who are there on the shop floor.
He has
What
said
what
synergenic the protection is absolutely essential. But anyway, it is a very wonderful presentation, I should say. Open cleanliness.
exactly?
70 nanogram is something it's great achieving. Anyway, please.
Yeah. So with that, we'll move on to our next speaker, who also happens to be the sponsor of this event today, Mr. Tiago Tuccetti Maya, CEO of Veta Technologies, a company from SMS Group. And Mr. Lizio is in a location which is very close to the SMS headquarters in Düsseldorf. And Mr. Maya is based far away in Brazil. That's where Veta Technologies is from. And I think Dr. Maya, it would be nice if you could introduce Veta Technologies a little bit before you move on to your actual presentation. Over to you, Dr. Maya.
Sure. I will share my screen. Please confirm that that you can see it.
Yes, we can see the screen.
Yes. So it's an honor to be here with you today. And as you mentioned, Veta is part of the SMS group. And we have most of our people now in Brazil. However, as part of the group, now we are part of a global organization. And what Veta brings and does, in essence, we are a center of competence for energy and sustainability digitalization. So digitalization is what we do at the core, basically using digital technologies to make steel makers more and more efficient every day. Sometimes this includes health issues. All the time, it includes environmental issues. In most cases, almost all of them, it includes efficiency measures that are tangible and become and are translated into reduced costs. But it's wonderful to see some of the developments in the technology of processes such as coke making. However, we do a complementary work in addition to the development of the processes by themselves on the process technology. We do the same on the digital side. So all the time creating new technologies, deploying new technologies to make steelmakers more efficient. And unfortunately, given the pandemic situation, we haven't been able to get around as much as we'd like. So most of our people are stranded in either one of our locations in Europe or in the United States or in Brazil, where we have a large contingent. But hopefully this too shall pass, and we'll be able to resume things in person in addition to the work that we already do remotely. So let me bring to you some of the things that we've been doing on the side of coke making, or including coke making. But just as a reference, we are in the business of energy and sustainability digitalization for steelmakers. If we consider all the energy that we manage with our tools today, the responsibility of our teams, that is already equivalent to all the electricity consumed in a country such as Argentina, our neighbor, or the Netherlands, Germany's neighbor. So it's already a fair amount of energy. And obviously, the steel business is quite energy intensive. And to us, our policy or our philosophy is where there is a lot of energy, there's usually also a lot of complexity. And when you have that, you have opportunities for improvement, and that's what we try to discover and address. So I will try to give you a few examples. So we've been working with this for 20 years. So dozens of references, hundreds of sites worldwide use these type of technologies, including the one that I'll show you today, which has a lot to do with making the results of coke making more efficient. So as you may be aware, of course, coke plants produce a rich gas. It's not the single gas on an integrated site, but it's quite a rich gas. However, what to do with the gas is not always something straightforward. So very quickly, of course, we have the coke batteries in coke oven production, as well as other gas sources. This is just a very generic diagram. You have gas being produced on the blast furnace. You have also steel shop gas on, for example, on the converters. And each site has a unique setup in terms of how this gas may be mixed in mixing station, in addition to the cleaning stations, how this gas may be enriched with an external gas source. For example, natural gas is rather common, not the only one, but rather common. And each site has a unique way to distribute this gas to all the industrial consumer, reheating furnaces, sometimes the same processes themselves, and also many sites, especially integrated sites, they have fairly large electricity cogeneration plants. So this is a setup. Of course, there's a lot of, I mean, you could have a heat recovery coke plant, which is slightly different. Sometimes you have steam turbines, sometimes you have gas turbines. So there's some variations there. So as you can see, as production is executed, there's a lot of things going on and a lot of decisions on how to mix the gas, when to increase the fuel rate or when to decrease the fuel rate. And in the end, a lot of people are trying to avoid flaring a rich energy source that could be best utilized either to generate electricity or to save on support gases, which has a direct implication in CO2. So this is a challenge that every integrated site has, and it's something we've been addressing for some time already to try to optimize. So again, the problem is, of course, the flares are there, including for security measures, and it's not possible to use 100% of the useful gas. However, how much useful gas do you actually burn? When we see the indices from many companies, it's evident that there's room for improvement. So for reference, for some types of gas, coke oven gas, blast furnace gas, which have a more constant throughput, it's common to see less than 10% waste indices in many sites. Sometimes you have sites with 15% waste, 20% waste, and that's a clear opportunity for improvement. For other intermittent gas sources like the converters, then it's common to see indices of more than 50%, sometimes it's almost 70% of waste. So there's an awful lot of energy that is wasted. When you're burning things on the flare, in many cases, you have to use other gases, natural gas or some other type of fuel, to do the same job. So you're burning twice instead of burning only once, which obviously has an implication in carbon, which, as we were discussing, this worldwide trend regarding safety, employee safety, there's obviously another worldwide trend regarding sustainability in general, and the one that really affects the steel industry is CO2. in addition to the rest. So again, if you're burning this, you may be burning twice for the same purpose, or not being able to use the gas, which could, in some sites, be converted into electricity. So there's room for improvement everywhere. So let me show you the type of approach that digitalization can do to solve that problem. As you've seen, there's a lot of people, a lot of areas, a lot of processes that need to be very tightly integrated and work harmoniously for these things to work efficiently. That is the theory. In practice, you have siloed thinking, you have conflicting objectives between the production sites and the utility sites and the power plant and so on. So not always easy to solve. And this, to me, is exactly one of the key roles that digitalization can do. You have a lot of people, you have a lot of processes, have a lot of areas. So let's bring them all together under a unified umbrella. So let me show you a technical solution for this. So we've been working, as I said, on this for nearly 20 years, and several problems for steelmaking. So one of the things that is very, very common and the basis of the work that we do is try to create models. Now it's very trendy to say artificial intelligence or machine learning. 20 years ago, it sounded like science fiction. So to us, it's not a matter of trend, but simply a tool that we've been using for decades. But anyway, we can create models that enable us to predict what's going to happen with that particular equipment with a fair amount of precision, including different operational conditions, which again, refine models and gives us a lot of precision. More and more, we're seeing that all sites have some sort of integrated planning or some sort of digital way to convey what's going on. So what we usually do is we connect to dozens and dozens of systems that are spread out through the entire site, where each gas consumer in a few gas generating processes work. So we're able to retrieve how this processes should be executed according to their orders. And of course, everybody knows when you have a good plan in place, it's not always followed. So especially if you're talking about fine sequence of production orders, sequenced orders, you have operational issues all the time. So it's common that take the converters, for example, you're supposed to start a heat at a particular point in time, but you have an operational issue. You have to start a little bit late, and then it finishes a little bit late, or you may start early for whatever reason, and then these plans become a little bit different. But these differences, in many cases, are the troubles that do not, or that hurt this type of integration and global optimization that we are talking about. So for us, we do a lot of automated, again, deploying some models and AI to do this. But in essence, we can read from thousands of signals coming from the instrumentation, patterns that tell us that this order is going to be late, or that order is starting now ahead of schedule. So we're able to really to criticize what's going on and get a precise time slot of when things happen. When we get orders from one side and we know the behavior of processes on the other, we put these together. So when we put this together, and this is a primary job of anyone working with energy in a steel mill, we should be able to produce a mass and energy balance. So we basically lay it all out. It's an automated process, but we understand the entire mass balance, how it behaves, where the gas is supposed to go, and also where you may be forced to flare. So one very common aspect is the relationship between gas production, gas consumption, and a little piece that is sits in the middle, which is the gas holders. We're used to seeing gas holders as those huge buildings or huge structures, and we think they're very big, but in essence, they're very small compared to the job that they're supposed to do. A gas holder is most often used or pragmatically used to keep pressures. However, it has very little storage power because the flow rates are so high that an entire gas holder is only able to cope for a few minutes. If you talk about, for example, coke oven gas. So in essence, we don't have a storage capacity. So we have to juggle all the time between production and generation. And whenever there is a mismatch, you're forced to burn gas in the flare. So lastly, we put this all together in an integrated package and run global optimizations on top of it. I think this is one of the most interesting factors that the latest digital technologies can bring to industrial operations in general, which is instead of just monitoring, which we've been doing for decades, or enable engineers or operators to simulate a million things, which we've been doing for maybe 10 years. Now, more and more, we can tell the machine to, instead of letting me simulate a few things, why don't you simulate a few billion scenarios and tell me which one is best? So this is what we do. This is our approach. And usually we're able to fine-tune gas mixing ratios. We're able to fine-tune fuel rates. We're able to show the impact of shifting a certain heating time delayed a little or started a little bit earlier, and many other parameters. But in the end, we're telling the machine to do its job and come up with a better answer. And the results are really, really nice. So I will show. Lastly, I know we are focused on coke making. However, there's a few things that are very common everywhere we go. When we talk about steel production, not everybody on the productive processes or take energy efficiency, carbon emissions as first priority. The most common thing that we see is I'm focused, number one, on my production. I have to tend to my volume quota, and I have to tend to my quality parameters. If I can do this spending less energy, that's fine, but that's not my priority. So what we came up with, this is especially nice for batch-based operations, is a non-intrusive way to help operators do their job a little bit better. What we came up with, again, is a concept of a go, no-go system, which has been used for decades in many other scenarios, but basically that run dozens of analysis, sometimes hundreds of analysis that includes simulations of the entire grid, analysis that involve taking the availability of say, nitrogen to cool a converter or electricity demand to run something else over the entire site. So we run hundreds of analysis and we give operators a very simple semaphore. If it's a red light, you should not start a heat, for example, because you may not have enough support from the site to complete it. I've seen so many times operations where operators start a heat and they're forced to stop. They run out of energy, very common. They run out of nitrogen, as I said, to cool the converter, very common. Anyway, it's interesting to give the operators a tool to do their job better. And this also helps with their engagement in taking on the energy reduction challenge. If you're giving a yellow light, then you may proceed with production. However, you may run into inefficiencies. Again, with the example of the converter, very common. You have two converters. You can recover gas on only one of them. So if you fire heats simultaneously, the gas that could be useful to do useful gas is forced to be burned on the flare. So we don't want that. However, when the operator is given a green light, that is all systems go. So hundreds of analyses have ensured that things would take place. So this is just one example, one use case that we do. In the end, our customers enjoy reduced flaring, of course, a reduced carbon footprint if you don't burn things twice, increased electricity generation, which is a key element along with reduced support gas. It's a key element to justify economically doing this in addition to carbon. So the reduction of production costs, plus what I just mentioned, that using that type of analysis where digitalization is looking at hundreds of scenarios everywhere, you reduce the risk of production. Usually, based on our experience, we're able to reduce more than 50% on flaring indices. Sometimes more. It depends on what type of gas, it depends on what type of flaring, but that already sets the bar in terms of expectations. And just to give you, to finalize and give you some other examples, energy in a steelmaker is a big topic, of course. Sustainability is something that is pushing everybody to be more efficient. So just what I shared with you today is just one example of the things that we do, just to give you a few more without further delay. We are often working on the efficiency side. We are also working a lot on the planning side. There is such a thing as paying less for the same amount of energy, because all contract structures, they are very dynamic in a steelmaker. They're not fixed like the contracts that we have in our homes. So when we explore these two things together, we can drive very significant savings to our customers. And just to show a couple of examples, this is an example of a similar thing done in a ladle furnace. I love this example because the customer, Valorite, was so happy with it. They wrote a paper and the case became public. So we are at liberty of revealing who the customer was. 6% reduction of electricity consumption directly, just by using digitalization, not a single change in the equipment, just ensuring that operators did their job slightly better and they knew what to do, when to do it. Obviously, when you reduce electricity consumption, a lot of savings also in electrode wear and refractory wear. Another example for an integrated site, more than 1,000 assets being tracked in real time, AI models being applied in real time, AI models telling operators, you're doing your job right, you're not doing your job right, this is what you should do here and there. Together with the leadership of the plant, they were running an overall efficiency program, and together we promoted 3% reduction of the total energy and utilities measure. So that's a fairly significant result, fairly significant financial advantage that they gained. Another one very, very interesting that brings the planning perspectives and contract optimization together with the technical efficiency of processes. We created a centralized management room for 22 steelmaking sites. They are all tracked in real time. There are efficiency measures being taken locally, but the central management office is concerned with planning, contract management, and budgeting. These processes involve hundreds and hundreds of people from the 22 sites plus the central office, and it's all run by this type of digital technology that we provide. For this office alone, they have more than 600 energy and utilities contracts. It's a few $billion per year worth of contracts. that we manage, or our platform manages with them. So fairly significant cases. I thank you for your time and for the opportunity of being here. I hope I could show you one example of how digital technologies already touch on the coke making side of the steel business, and also some other examples. But my final message would be, as we've been seeing with all the trends and as technology matures and it becomes more and more available, digitalization is a path for optimization of results in the steel world. And to us, as mentioned, results include direct cost reductions. Of course, it has to provide a cost advantage, otherwise it wouldn't make sense. But in parallel with this, we are assisting with the energy transition by reducing energy requirements and, of course, emitting less CO2 in the process. So I thank you all. And if you have any questions, please let me know.
Thank you so much, Mr. Maya. And it was once again another aspect we are all looking into, which is the effective digitalization in all spheres, including in the coke ovens area, where I'm sure Mr. Vijay Sharma, who has just joined us, will also notice how effectively we can improve our coke oven productivity, at the same time produce more electricity, which is a favorite subject of Mr. Vijay Sharma. In fact, that is where, and I was really surprised to note that the payback period is only between 6 to 9 months. I mean, so that's a pretty fast payback period, I would say. And with that, thank you once again, Mr. Maya. You've joined early in the morning from Brazil. And, you know, I know situation in Brazil is not too much, but I mean, too much different from what it is in India. So we are both suffering, and let us pray to the Almighty that we recover as soon as we can from this pandemic, especially this wave, which seems to be more dangerous than the previous wave. And let us all get back to our lives as soon as possible. With that, I'll move on to our keynote speaker, Mr. Vijay Sharma, who had some technical issues. Our server was down. He got disconnected from us. So, Mr. Sharma, I'm sure you must have, anyway, I will send you the recording also of Mr. Peter Lizio from ThyssenKrupp, who had made a wonderful presentation, and also Mr. Maya from Veta Technologies. So with that, the floor is all yours, Sharma sir.
Thank you. Thank you so much. Good afternoon, my friends. Good afternoon, everyone. I'm sorry, in between I got disconnected, but I'm back to the webinar. So it is a very wonderful webinar. I listened Mr. Maya a lot, and he's right how to do the digitization and what can we do in the new technologies. I will add something for the August gathering and all the participants and listeners here, that we have devised a new use of coke oven gas, and that is making DRI. So we are now, we used to produce DRI of 250 ton per hour DRI plant. We are consuming around 90,000 tons of, 90,000 cubic meter of syngas, that is synthesis gas, and about 40,000 nm cube of COG, that is coke oven gas. So 40,000 nm cube of COG is equivalent to around 50,000 of syngas, because COG is having 4,100 calorific value, and syngas is having 3,300 to 3,400 kilocalorie. So the usage of, this is the first time anywhere in the world the coke oven gas is used commercially in such a big way. Now we are working how to increase from 40,000 nm cube to 50,000 nm cube. Hopefully we'll be in a position to achieve it. This is a technology what we have developed over a period of last 8 to 10 months time. So we have to thereafter see whether the coke oven gas to be used to produce power or to be used to produce DRI. So in our view, we have found that power gives the less return when we compare with the utilizing chemical energy of hydrogen and carbon monoxide present in coke gas, and why not to utilize this to produce DRI. So we are now also working how to reach to a level of about 70-75% of the total coke gas to produce DRI. We are adding one more DRI plant in India, in our Angul plant. So there we will be utilizing most of the coke gas to produce DRI. So this is an innovation, first time has been done in the world. In fact, we discussed this thing about 10 years back in a Midrex seminar in Egypt, that can we use the coke gas, but at that time, Midrex was not ready with this kind of technology. Similarly, we discussed with HYL, that they also, they took some interest, but since nobody was there, nobody was using this gas to produce DRI, so they were also a little, unresponsive. But finally, we found within 2 months' time, both the 2 years' time, both Midrex and HYL, they came with their own suggestions that yes, coke gas can be used to produce DRI, and this is what we have done here. So most of the technology has been developed by JSPL only, and we have also taken help of some of the experts in the coke gas field, including the people from China, the people from America, people from Brazil, and also from Mexico. So this is what we have done. So in my view, the future of coke gas is not only for power or reheating purposes, but for utilizing the chemical energy and producing DRI. So the next is the whatever the coke gas today we have, I think there's great amount of cleaning is required, and there's a great business available in the country, because most of the coke plants which are already existing or the plants which are likely to come, they are coming with the latest gas cleaning systems. I'm sure the technology suppliers, they are working on this. We discussed long back German company Ude at that time, and we found that the technology is quite advanced, and this can be used in India. So now most of the plants which are coming in India are with CDQ, and this is again a good sign that we can produce power through CDQ route, but still that is utilizing the waste energy of the coke, whereas the coke gas, the chemical energy, the best use today is making DRI. As far as current situation is, it is a very peculiar situation. We are now working that today coke plants are in a big fix. The price of coking coal is low. Sorry, and the price of PCI has increased. So this is, a very peculiar condition. So we are also working that whether PCI should be increased in blast furnaces and use more oxygen, or save oxygen for the country so that we can meet out the oxygen demand for the patients, those who are COVID patients or those who are in hospitals, and reduce the PCI and increase the overall coke consumption. And because the coke prices are low today, because coking coal prices are low. So with $120, $130 landed price in India for the coking coal, so similar price coming for the PCI, whereas PCI is having higher ash and a lower calorific value, and coking coal has a lower ash and higher calorific value. So we are working in our Angul plant and also in Raigad plant, a right mix and right blend, how to save oxygen in the blast furnaces, and side by side how to keep on maintaining the production in blast furnace. So these are the new developments I wanted to share with the team, because more we disseminate knowledge, more we discuss with people, so more solutions will come. So the subject today taken, operations of the coke ovens, is a wonderful subject. In India, especially, the coke ovens are still being fed by one or two kind of blends, whereas the countries like Japan and Korea, they are using 10, 12, 14 types of blends to feed the mix to their coke oven plants. So I think India has to catch up in this kind of technology so that we can reduce the overall charge mix prices. So today the coking coal prices are low. Maybe tomorrow the prices, when they go up, at that time it will be difficult to control the cost. So I'll invite all of the technology suppliers, all of the right blend suppliers, the level 2, level 3 system suppliers and automation suppliers, and how to save electricity, or how to save the wastage of coke oven gas, and how to extract the last molecule of recoverable substance from the coke oven gas, so that coke oven gas which is going in the plant, whether it is for reheating purposes or for DRI or for power making, we should be in a position to get the most clean gas to operate with. So these are my few suggestions which I wanted to discuss, though it is really different than the others, how to utilize coke oven gas to produce DRI. And we are quite happy, and we found it is a very friendly gas, and we'll be happy to put up the second plant based on about 75 to 80% of coke oven gas, and 25% is syngas. So thank you very much.
Thank you so much, Sharma Saab. And I know, it is Mr. V.R. Sharma who has turned around this company with a clear frame of mind. What is more beneficial? Is it more beneficial to produce DRI from COG, or is it more beneficial for me to use it otherwise? Or should we utilize it for only DRI, because that is where we get the maximum energy benefit? So that is what has helped. And by the way, those who are not aware, let me tell you, Jindal Steel and Power has now virtually exited from the power business, because by virtue of selling the majority stake in Jindal Power Limited. So there again, I believe Mr. Sharma had a major role to play to suggest to the promoters that it is more beneficial actually to invest that kind of money in the steel making business, where I'm sure the margins are higher than what you get by selling power. So I know Mr. V.R. Sharma for quite some time now, and I know he is a person who can turn around the business in no time, and he has done it in a shortest possible period of time. The company had really gone into not so comfortable situation, and from that he had Mr. Sharma has virtually turned it around. So once again, kudos to Mr. Sharma for what he has put in turning this company around. Maybe Mr. Peter Lizio, would you like to ask anything to Mr. V.R. Sharma?
Yes, Mr.
About your experience from ThyssenKrupp.
Yeah, Mr. Sharma, thank you for your wonderful advices, because it was very interesting for me, especially for my mother company, ThyssenKrupp. We are in a period of decision. European conditions for steel making are really strong, because this year, 2 times the price for carbon dioxide emissions popped first time above 50 euro per ton. That's a huge amount of money you have to pay for carbon dioxide. And maybe we have election in the autumn of this year, and the Green Party will get a big influence of German polity. And we are operating 4 blast furnaces in Duisburg with a total capacity of maximum 33,000 tons of hot metal. And we're looking for a greener future. First step is that we have done tests with blasting in hydrogen in 1 blast furnace. It should be fully equipped with hydrogen, extremely expensive here in Germany. I'm a coke oven guy. I can't understand this decision. I would blast in coke oven gas, because with my plant, I'm producing 160 up to 170,000 cubics per hour with 63% of hydrogen. That means per hour, 100,000 cubic of hydrogen. If you take a standard PSA technology of the pressure swing absorption transferred by Linde or Udi, you can get clean hydrogen. And that is the stuff of future for all politicians here in Germany. Now the guys are thinking about a DRI with 2 million tons of capacity and want to operate with pure hydrogen. In my opinion, crazy. So I think the better way would be start with methane, or that's the point I'm interested in your speech, coke oven gas. Because you have your high amount of hydrogen, 63%, and 20% of methane. So the footprint for the ecological thing of the Green Party, if you think political, is much, much more better when taking methane. And when we're displacing coke oven gas out of the entire net, then we buy methane from the Russians or from the overseas, or whatever. So I think it was very interesting for me to get your thinking, because we are so crazy, we take coke oven gas for incineration in the steel shop or in the rolling facilities. I think it's such a nice product mix. When I go to China, last year, February, I was in Yangquang, and they have owned the best. In 1993, in Germany, we built up the coke oven plant Kaiserstuhl. It was a state of art of coke making in 1993, and they shut down the work in 2000 when we start up our new plant. And this plant was sold to China, but bought by Yangquang. They established it once again and are operating. And they have no connection to a gas net. They transfer on the side all the coke oven gas into 200,000 tons of methanol per year and selling the methanol. All Chinese coke oven plants, they are producing 40 million tons of methanol, which is displacing petrol, because they're running petrol with 5 or 10% methanol in the petrol. That's the way in China. But your way is quite a good way, and I will promote it in my company. But I'm only the coke oven guy.
Thank you. So, the methanol is possible, but methanol is a very low value product, because in India, the methanol is available today at 30 rupees. So 30 rupees means, if you see, then it is only, if it is 100 cents, 75 rupees, so it is about, say, 35 cents. So this is too cheap a product. So methanol, we didn't go purposely for methanol. And yes, you're right, we can produce hydrogen through the CO shift route, and we can convert the CH4 and COG through CO shift, and we can produce the entire hydrogen. But again, hydrogen, utilization of hydrogen up to level of 10-15% in the blast furnace or in the DRI plant is okay. But utilizing 100% hydrogen, I agree with you, this is not the right solution. Yes, for the technology demonstration, we always say that we'll use hydrogen in blast furnaces or on DRI plants, but that is only for the technology demonstration. But for the commercial use, the best is to utilize the coke oven gas. And when we have so much of methane in the coke oven gas, about 20%. So you need to complete the cycle. So you need to inject in the bustle, you to inject the oxygen. So when we have the CH4 and plus oxygen, so then we convert a complete cycle, CO2 plus hydrogen, and that gives the right gas for the DRI plant. So what we are doing now, I'm sharing the technology very openly to everybody, because the people, they say that coke oven are not the friendly machines, but coke oven is a very friendly machine if we use it rightly. So people up till now were thinking coke oven is an environment damaging machine. It is not. If you take out the CO, you take out the hydrogen, and you convert methane into a perfect burning in the presence of oxygen, so then you take out at least 75% as hydrogen from the CH4, and that is the game. So you reduce CO2 and you increase hydrogen. This is one. So this is what we have to see always. Then the coke-oven gas is so friendly that people are yet to discover the chemicals, the precious chemicals we can take out from the coke-oven gas. And now the people are working, though it is already people have discussed work. China Sinfuel has worked very closely. A substitute to needle coke, and the needle coke can be substituted with coke-oven gas, and we can produce a substance or the raw material for the electrodes, for the electric arc furnace electrodes. So that is again a very good product which we can take out from coke-oven gas, and we can utilize it to a right level. So then next is coke-oven gas can be converted as a synthesis natural gas. So today coke-oven gas, people are just thinking it is a gas for flaring, but coke-oven gas can be converted into SNG. SNG is synthesis natural gas for the cooking, for the cooking purpose. So we add the right blend, and we can replace LPG, and we can use coke-oven gas as a domestic gas. So today we feel that yes, domestic, there's a carbon monoxide into it, and we can't use it. But if we convert, if you dilute carbon monoxide to less than 5%, then the coke-oven gas is the best gas for this cooking purposes. So the problem is today the whole world is behind coal. People say that coal is bad, coal is bad, coal is bad. I don't know why coal is bad. So coal is not bad. No. The uses, the way we are using coal is bad. So when we say that we are using coal as a thermal power plants through Rankine cycle, so we get only 28 to 30% of the efficiency. But when we use coal through the syngas or synthesis gas, through coal gasification or through coke-oven coal gas, and we put into a combined power plant, combined cycle power plant, we can get 58 to 60% efficiency. So from 32% efficiency to 58 to 60% efficiency, this means how much carbon we have saved. So now, people, they always say that solar is the solution, wind is the solution. In my view, I have a little different view. The wind and solar is not the solution to the world. The solution to the world is a mix of various energies, various source of energy. Wherever there is a sun in the developed countries, or in a country, tropical country like India, wherever there is sun, there is a farming, there is agriculture. So if you put the solar plants wherever the sun is, that means you are going to sacrifice the crops. You are going to sacrifice the agriculture. And today it looks very nice, but after 10-15 years, when you have to replace this solar panels, then it will be another big problem. So is the winds. Okay, we must try. We keep on trying the windmills and the solar. I'm not against that, but we should simultaneously we should see how to utilize this most economical gift of God given to the mankind, and that is coal. That is coal. So people feel very proud that coal, oh no, coal is not good, coal is not good, coal is not good. So then what is good? So even in India, I tell you, we have more than 70% of the total energy comes from coal. Up till 10 years from now, in London or in England or in Europe, it was coming 65 to 70% through coal. So coal is more friendly than nuclear. Coal will never replicate, or coal will never put a trouble to the people like Chernobyl has done. So in Russia, so coal will never be unfriendly for the mass destruction of the people. But the nuclear power plant can be mass destructor of the mankind. So we feel that we must use coal, but we must use coal in a very, very clean and healthy manner. Yeah, we must convert coal into gasification. Like we have a plant from Lurgi. So Lurgi is the technology supplier. They have given us a plant to produce coal to syngas, and we are very happy. So in times to come, like India is having more than 400 billion ton of coal. So the solution for India is neither it is fossil fuel, the petrol, benzene, or crude oil, nor it is a nuclear. For a country like India, the most friendly source of energy is coal. And coal should be used through the coal gasification. And the coal gasification can be underground coal gasification. It can be above the ground coal gasification. It can be coal bed methane and many more. The other area which is now missing in the world is the how to utilize coke oven gas to produce ammonia, because ammonia is a product, and NH3 is a product which is especially in India we are still importing. So I discussed with some of the coal planning people, and I told that why not to convert coal into ammonia. So these are many sources, many areas where we can do so many things. So over to you now.
Yes, Mr. Lizio, before you respond, I'll request an opinion from Nippon Steel. Dr. Saito, do you have a different opinion? Yeah, Dr. Koji Saito from Nippon Steel.
Yes. I just come back to my drinking time because already I mentioned to the in Japan we have a holiday time. Arlene, you so well, but anyway, so hydrogen is a very, very difficult time to the timing in the also all of the new world, especially so hydrogen is very difficult to the control of the volume and quality. So I'm wondering because in India, how discussion about hydrogens in India, how to control that? I'm not sure that. Please refer about how to control the hydrogen in India, so into in the world. I'm not sure about that. Thank you.
I will give one sentence reply. Thank you. So you told me that it was your drinking time. So it's good. So enjoy the Asahi. So you must be enjoying the Asahi or Qingdao. Okay, good. Very nice. So the point here is hydrogen. You're right. It's very difficult to handle hydrogen. And hydrogen, we do not want to utilize 100% hydrogen or hydrogen into for the DRI or hydrogen into blast furnace. Sometimes, the technology becomes a very fancy word, and people feel that if we don't speak on this technology, then we will be rated as outdated. So it is not that. We know that the things are to take shape accordingly. The hydrogen as a hydrogen fuel cell is all right. Hydrogen as a media or as an inert gas is an excellent gas, and we must utilize it. But hydrogen as a fuel is not a very good gas because you spend more than 400 times on the safety parameters. The hydrogen is more dangerous or equal to the nuclear power plants. So you have to have a very balanced view. So I'm from the old school, so I feel that we must have a very good balance in between hydrogen, carbon monoxide, and also in terms of coke oven gas or syngas. So this is the region when we have syngas, we have 58 to 60% hydrogen, and we have about 28 to 30% of CO, carbon monoxide. So this is the best combination, so that it is not in the extremely explosive range. We can transport it in the normal mild steel, carbon steel pipelines. We can use it through the normal normal valves and fittings. And in case of any leakage, we can detect because carbon monoxide will start giving the alarm, which hydrogen will not give. And these instruments to check the hydrogen leakage are very, very expensive and not yet fully developed in the world. So hydrogen for the satellites, it is okay. And launching a rocket, hydrogen is excellent. It is okay. But in steel plants, I think it will take some time and before we mature the technology. So I agree with you. How to handle hydrogen is going to be a bigger challenge than how to handle the nuclear power plants. So in nutshell, the story is we must use 58 to 60% of hydrogen, 25 to 30% of carbon monoxide. We must use syngas. We must use coke oven gas directly, having CH4, say about 20% or 18%. We must burn CH4 to do the complete combustion cycle in the bustles of whether it is blast furnace or it is DRA plants. So in the bustle, we must burn it CH4 in the presence of oxygen, and we must complete the cycle CH4 plus O2 is equal to CO2 plus hydrogen. So this is what we have to do. So when we do this, then we can find the right balance. And again, I repeat, coal is not a bad product. Coal is a very good product. Uses of coal and type of use we are doing, that is wrong. We must change the usage of coal. Otherwise, it will be very difficult. In 1960s, Japanese were the solution provider to the world. The complex problem was solved by Japanese by simple technology. Today, the complex problems are solved faster by Chinese teams, Chinese engineers. They are the expert. The very, very difficult problems, they find the easy solution of the difficult problems. This is their skill. This is their characteristics. And sometimes the whole world we miss. We find a very, very complex problem even for the simple issues. So we have to find out, and we have to advocate for coking coal, for coal gasification, for uses of running the right and effectively the coke ovens in anywhere in the world. And this is what we have to do. We should not feel that coke oven gases or coke oven plants are spoiling the universe. It is not. It is not that, because who spoils the universe? It's not coke oven gas, but the tissue paper industry spoils the world the most. The paper cup industry spoils the world most. The plastic and paper crockery spoils the world most, not the coal. And this is what I wanted to tell you. Thank you.
Thank you, Sharma Saab. Andrin, I believe you wanted to ask a question.
Yes.
Peter, shall I come back to you after Andrin speaks?
Yeah.
Andrin had a question. Yeah.
No.
Andrin, yeah, go ahead.
Mr. Sharma, it's always very, very interesting to listen to you, and especially the viewpoints of me and you related to coal is very, very similar. And I believe Peter would be one of the happiest persons to be here to hear your good viewpoints about coal, because in Europe, we are really, really having a tough time from the green lobby. And the problem is virtue signaling. The politicians who are asking you to take a cycle to go from here to there, they are taking themselves the chartered flight. So this is all a matter of virtue signaling. But however, I'm a little bit different opinion related to the nuclear power plants. The same way I love coal, the same way I also love the nuclear things. The reason being that two of the big disasters, one Chernobyl and the second Fukushima. Chernobyl was an unprecedented human error, and Fukushima was the tsunami. So the odds are very, very low in the present world. Having said that, just a couple of questions related to the extremely interesting topic of making DRI using coke oven gas. So first of all, I assume you are doing it in Angul, right?
Yeah.
So you are coupling the coke oven gas directly to the mid-range shaft?
Yeah, directly.
Or is there a reformer in the middle?
No, there's no reform.
Okay, so it is used as it is
as it is, and only for CH4 we inject CH4 we burn CH4 in Basal, just outside the coke oven kiln.
Okay, and there is enough gas available to power the coal gasification, the mid-range shaft after heating the blast furnace stoves and the reheating furnaces. So there is still enough.
And we don't use coke oven gas for the blast furnace. We use blast furnace gas only, and also for coke oven we are using blast furnace gas.
Okay. So this is a very good. And the reheating furnaces in the rolling mill, what type of fuel?
Yeah, mix of syngas, mix of coke oven gas, mix of LD converter gas, and partly the coke oven gas. So because we need to have around 2000 kilocal.
Okay. So after
Andy, I just suggestion about the volume. So balance. So volume, methane value, methane for utilization for the blast furnace, which is both best utilization in the world, like that. Always we have to discussion about the volume of this balance of that.
Did you get the question, Sharma sir?
No.
Can you repeat, Mr. Saito?
Yes. I'm just wondering that the important things is the volume. Of course, hydrogen is a very important thing, but so hydrogen for the blast furnace, we need very, very high volume of the blast furnace for the gas. How to get that? It is very difficult. So it means that we have to discussion about the balance. Gas, or of course with the hydrogen, of course with the methane, or of course some another gas. Always we have to discuss that. That is my point. That
you're right. I agree with you. The hydrogen, though we have not used so far in blast furnace, but in our view, it should not be more than 10% in blast furnace or in DRI. And whenever we will take a trial, we will start from 5 to 7%, and slowly we will increase because the stoichiometric ratio is 4% of hydrogen. So we will try with a little above the stoichiometric ratio, and which can be say about 7-8%, and then finally slowly gradually we will increase to 10-12%, not more than that. And we will not use hydrogen as a fuel, but our aim is to use hydrogen as the lightest gas. This will, because the molecular weight is very low, so this will be the lightest gas, and this can reach from all through from coke and iron ore or pellets right on the top. So our purpose is the hydrogen to be utilized as a carrier for the heat, not to heat. So there's a big difference in two technologies. Yeah. So we are going to utilize hydrogen as a heat carrier. Like for example, and there are bell type annealing furnaces. In the bell type annealing furnaces or the continuous annealing furnaces, we are using 100% hydrogen as an inert gas. So we are not using their nitrogen, and that means it carries heat faster. Like the companies like LOI in Essen, or it is Ebner in Austria. So they are the leading furnace suppliers, 100% hydrogen furnace suppliers. So these hydrogen furnaces does not mean that hydrogen goes to the burners. No, it is a purge gas. It is a gas inside the atmosphere so that it can protect the atmosphere and no oxidation takes place. And hydrogen being the lightest gas available in the universe. So this penetrates in between the layers of cold rolled coils, and we get the better properties and uniform properties. So we would like to utilize hydrogen not for fuel. We will like to utilize hydrogen just as a carrier or as a facilitator to take the hot blast air up to the top of the blast furnace, and so that our cycle time is reduced to about 20 or 25%. So today, if we are getting one tap to another tap, there is a difference of, for example, 10 minutes. So this will become maybe 8 minutes or maybe 6 minutes. So the total charge mix, what we are seeing that it comes down in say 18 hours time. But when we have the hydrogen, the total charge mix will come down and it will melt away maybe in 12 hours time. So it will increase the production. So hydrogen has two uses. One is to be used as a carrier. The other is to be used as a fuel. So our intention is to utilize hydrogen as a carrier, not as a fuel. And fuel, we are too far away. We have to see what is the world doing and how the world will do it. And maybe it is a question of about 10, 12 years, but for sure in next 3 to 4 years, we'll be utilizing hydrogen as a carrier, not as a fuel.
Oh, Mr. Sharma, thank you for your comments here. You are speaking from the heart. I'm born here in Germany in a mining company, 200 close to a mine and 200 meters close to a coke oven plant. I was born in a house, so all my youth was with coal. And former times I've studied teacher. I'm a teacher for chemistry and sports, and then I was unemployed. I'm looking for work. I was 2 years underground, and underground in Germany, that means 1,350 meters, really deep, was strong work, and I loved coal. And I'm exactly on your way. Coal is a wonderful gift by nature. It's a wonderful molecule cocktail, but we must be clever enough to use this cocktail. And the silly incineration is not the way of usage of coal. Coal is a chemical reserve. That's my understanding. But I'm working in a steel company. That's a fuck that you have only metallurgists around you and no chemical guys. So for me, it's not the right way we are doing that. We burn our coke oven gas as a fuel. And we must have, okay, we have done a lot of tests injecting hydrogen in one of our blast furnaces. We learned that the big stress for the wearing of the blast furnaces. So hydrogen attacks the wearing of a blast furnace in a very sensitive way. It's something nobody has studied up to now. We are just doing it. And we are in the development, in a kind of research that we learn. It's not a long-lasting way of operation. So we have taken our oldest blast furnace for this investigations. And we are well promoted by the Green parties with these actions we are doing now. But as Mr. Sharma told us before, I think coke oven gas is a wonderful fuel for DRI, and they want to install 2 million ton DRI plant. So, but they are thinking about hydrogen and methane. That means natural gas, and that's not my way of thinking. And using my coke oven gas in the power station, crazy. But okay, now my friend has left. If he stays in Germany, I drink a German beer. He's my guy. So now I close my mouth.
Yeah. So Mr. Saito.
Peter, so I have some opinion about that. Of course, just a great technique to apply to the hydrogen to the blast furnace. Yes, it's great, but sometimes it will be very difficult. That So it means we have to share the technique to the blast furnace to the sometimes to the another technique like that. So always we are discussing about that. But this meeting is a focus to the coke making. So
Yeah.
it means coke making. It means that we have to focus that. Always we have the focus about the coke making technique like that. So of course, hydrogen blast furnace, no coke making. So
Mr.
we just change the technique. Change of the technique discussion about what like that. Is that true? It's okay.
Yeah, Mr. Saito, when you are on the coke making side, like myself, and you love coke making, and we have only 5 coke making plants nowadays in Germany. I was born 1958. And in the yearbook of coke making of the year 1958, which stays in my bibliothèque, in our region here, we had exactly 58 coke oven plants. That's a number I can remain. 58 coke oven plants. Nowadays we have 5 incomplete big ones, but 5 in Germany. But when you are under pressure by these green parties, you cannot talk only about coke. You must have discussions with the other side. You must take their argument and you must beat them with their own argument. So you must understand the hydrogen business if you want to rescue your coke oven business against the other parties. So I'm doing everything. I'm very connected to the German chemistry industry, to BASF and Bayer, and also to Linde, which are talking about coke oven technologies, coke oven gas technologies, compositions. I was in a project where we make pyrolysis of methane, of natural gas, to get hydrogen and looking for the residual carbon and looking for usage of this carbon. I was in this team. I was already in the team of Carbon to Chem, where we talked about carbon dioxide as a resource, looking for the right catalyst and producing, taking coke oven gas, making PSA, taking also hydrogen, and then making methanol and urea and ammonia out of carbon dioxide, which is coming from the mill, from the blast furnace gas, and together with the coke oven gas. So we're doing a lot of things to be a partner for future thinking of the Green Party. You cannot stay on the old-fashioned way. It's not possible. You must think, you must take off your items here in Europe. I speak only about Europe, especially about Germany. We want to be the greenest party of the world. That's typical German. We want always to be the best. So we want the greenest guy in the world. It's not my word, but you must discuss with these guys. So you must understand their argument and find contra-argument. That's my way.
Thank you. So let's come back to when we set up to the top of the coke ovens. The nice preview and nice great job, like. So anyway, so we the coke ovens always a good job like that. So now we are here that always we discussing about the coke ovens, what are the operation like that. Oh, so anyway, so let's come back to the ending. So we have to do what's our discussion matters. Let's go back at there.
Dr. Saito, I need a lot of sake from you to survive this. So I'm waiting for your sake, and I'm sure Peter will keep a lot of alt for me when I'm there. So a good amount of alt and sake can only solve this problem. Exactly. So we'll go ahead with the next speaker, Dr. Amitabh Shankar, who will talk about what you want to hear. He is the head of coal and coke technology of process technology at Tata Steel. So over to you, Dr. Amitabh Shankar.
Yeah, good morning and good evening to all of you. Just a moment, I'm just seeing my screen.
Not yet. We can see you. Now you have to share the screen. Yeah, I know in Tata Steel you're not allowed, you don't use Zoom that much.
Yeah. Only my kids are using for the school, not for this. Are you able to see now?
Yeah, now you can. Now you can just make it full screen. Yeah. Yeah, perfect. Go ahead.
Okay, thanks. I picked up this topic from the list of the topics given actually, and we all know this coke quality is very important actually for the coke makers and as well as our end customer, which is basically the blast furnace. So I'm going to talk about that and how we can manage better coke quality and trying to incorporate some of the practices which we adopted at Tata Steel and some of the learnings and also some of the viewpoint from the other researchers. So the first thing regarding the coke quality, what are the vital parameters which a coke maker or the blast furnace guys are looking for actually? So the first of all the coke parameters, the most important parameter is the coke strength after reaction, which is basically the CSR. Now, when we talk about the CSR, it ranges quite widely actually. If you see some of the European practices, where it is operating around 58, 60, which earlier they used to operate around 65, 70 kind of thing. Now they have reduced the target, and even POSCO and even Tata Steel India and most of the companies in India, they are close to 68, 70. That is the target. Not normally they are keeping or 66 plus. So this property is mainly blend driven that we will see in some of the subsequent slides. But this parameter is very important actually. When we say it is blend driven and looking at the current dynamics of the coal prices, the way it is changing actually. The prime hard coking coal, very low prices, relatively low prices, PCI going on higher side. Even the coal like semi-soft or weaker semi-soft, non-coking coal, those prices are very high or comparable to the prime hard coking coal. But there are some other restrictions actually that we cannot use very large proportion of the prime hard coking coal. Now coming to the M40 or any coal strength property, this is widely also varying. Uh, One is that reason is that the way the coke is sampled, sometime it is sampled at the coke plant end, sometime at the blast furnace end. It's more representative in case of M40 or even the mean size if it is analyzed at the blast furnace end. In most of the cases, in case of Tata Steel, it is being measured at the blast furnace end. If we talk about the coke mean size, this range is also mainly for the stem charge operations. 52, 50, 52 is mainly for the heat recovery type of ovens. And again, it is also the process driven. M40 and mean size both are mainly the process driven. The way we handle the cooking time, set or some other parameters also related with the process. Apart from that, coke granulometry we also feel is very important actually. Normally we talk about coke mean size, but coke granulometry I want to emphasize because it is a parameter which you continuously getting actually, and in different forms actually. It can be either in terms of bridge generation, how much it is coming at different locations, either at coke plant or the blast furnaces, and even at the coke plant in, we continuously get this measurement at least 3 or 4 times day. So this measurement is a kind of continuous and more than compared to CSR, at least we can say, because normally the frequency of CSR measurement for most of the plant is once in a day. Then apart from that, the minus 30 millimeter fraction, this is also very important actually in the overall the coke fraction. How much is the minus 30 millimeter fraction? Typically, in our case, it ranges between 6 to 10%, and it also gives a lot of indication if it goes on the higher side. Apart from that, the coke fines and nut coke, these are also very important, although it is not the direct parameter to assess the coke quality, but in a larger perspective this is very important. Why? If the coke fines are higher actually, so our BF plus nut coke will be on the lower side, so the coal consumption per ton of hot metal production will certainly going to increase, and that we are also witnessing at our some of the locations actually. Similarly, if the nut coke is generation is high, blast furnace always want to use all the nut coke whatever generated. If the nut coke is high, then they have to use more of nut coke, and then they have some issue with the managing their coke layer thickness, and then coke rate has to be increased. So overall, the BF plus nut coke yield, which is going into the blast furnace, is going to go down with the higher coke fines and the nut coke. That is why this is also very, very important parameter from the cost perspective, certainly. Coke ash is also very important, and many coke plants in India and also the blast furnaces, they don't want to go beyond certain ash level. Uh, Tata Steel Jamshedpur, TSK, they are they are operating at higher ash level because of the domestic coal usage. And in last 1.5 year also, we have increased our coke ash level compared to previous years actually. But what we have seen even during the COVID period, we have increased forecast level to very, very high level, 19 to 20%. But at the same time, city was very, very higher on the higher side. But fortunately, that time there was no impact on the CSR, which I'm going to show in the subsequent slides. And M40 and MS, we saw some improvement. But we can say that it might be because of the very high cooking time. So we went around 50 to 55% of the domestic coal with ash of around 18.5%, which we did after I think a long time. Apart from that, coke master is very, very important because for a customer side, it is very important in the sense they see the variation impact of this coke master immediately actually, unlike the other parameters. And the coke master is also a kind of continuous measurement done at the blast furnace by using NMG or some other online measurement technique. So it is normally between 0.5 to 4%, depending upon dry quenching or the vent quenching. There is one more thing in case of coke master, which is at Jamshedpur, we are practicing, and I think at some of the other coke plants also this practice is used, which is basically the coke drying system, not the CDQ. Because in case of Haldia, we are getting the coke from the Haldia, which has normally dispatched coke moisture is around 3.5 to 4%. But during transportation, especially in the monsoon time or winter time, it increases and goes roughly 6 to 7%. So by using the cold blast air, we're trying to reduce it by 1 to 2%. And this is giving a lot of benefit actually. And now we are able to manage within 3.5 to 4% coke moisture at Jamshedpur also. Apart from that, the coke porosity is also very, very important, which is between 30 to 35%. At one of our coke plants, it is also used as a kind of indicator in case of if CSR is not available actually. So higher porosity means higher reactivity, so likely to impact the CSR. So these are the major parameters which what we think about. Some are very common and some are basically we are using and some other plants also using, but not so much talked about, especially the fine generation, the co-granularity kind of thing. And also I'm going to talk something in the coming slides, which we are using actually those parameters to assess the coke quality. Now, first coming to the cool blend, because we know that cool blend is a one of the vital thing because this is the input quality, which decide basically the what is the blend quality and finally the coke quality, and 70 to 80% we can say that coke quality is driven by the blend, the kind of blend we have. So typically, if you talk about if it is a 100% imported coal in the blend, it is around 9% as in the blend. Otherwise, it can go around 13.5 to 14%, depending especially for the domestic coal users. Blend VM, it varies between 22.5 to 26%. Lower VM mainly in case of heat recovery ovens, where there is some restriction about the boiler inlet gas temperature, which we want to restrict around 930, 940 degrees centigrade. That's why they want to keep it little on the lower side. And also in case of heat recovery, because of lower VM, there is no issue with the hard pushing and any other thing like that. So they are in position to maintain lower VM. Otherwise, normally 24 to 25% is the normal blend VM we operate. Blend moisture is between 9.5 to 11.5% in general. Um, Other property, which is basically the geological property, dilation or expansion, is normally between 10 to 30%. But we have some instances also when even going beyond this range, the coke properties are okay. But based on the literature and our practice, we normally try to maintain in this regime. Similarly, fluidity 200 to 800 ddpm is quite good for a good for achieving the good CSR 65 66 plus target. If we get fluidity more than 200 or 300, normally CSR is not getting impacted. Actually, it's a kind of flat curve. Apart from this property, plastic range is also very, very important for low rank coals. Normally it is on the lower side. So compatibility is not good. It not doesn't disseminate well into the coke. So that's why plastic range should be very compatible actually and bit on higher side, which normally happens with the tier 1 hard coking coals, which is basically prime hard coking coals. CSN, with our experience with domestic coal being on the lower side in terms of CSN, we found that even 5.56 level is good enough to maintaining the coke CSR and the normal blend property. Rank, normally we say that 0.9 or 0.95 to 1.2 kind of thing is okay. But normally we try to keep a target of around 1.05 to 1.1 kind of thing in terms of rank. Inert is also very important, especially for the cold strength or the mean size. But we have to also find out what is the optimum inert percentage for getting a good mean size. Actually, normally we operate around 35 to 40% range, and in one of some of our other coke plants, it is on the higher side. Apart from that, gas pressure is not directly related with the coke quality, but it's very important actually and decisive factor to decide the blend. Because like right now, the current crisis situation, right now our PCC prices are quite low actually. So it gives us liberty to use more of prime hard coking coal or tier 1 hard coking coal. But at the same time, since some of these coals are with very high gas pressure, so it is not very good for the battery health perspective. So that's why we need to keep a watch on the gas pressure also. Now it is a bit tricky thing how to keep a track on that, because a lot of tests are required to understand what kind of gas pressure a particular blend is exactly. But directionally, with higher gas pressure coal, certainly the blend gas pressure is going to increase. Apart from that, cussing fine is also very important, and normally we try to keep a target of 88 to 91%. For heat recovery ovens, slightly lower side, 86, 84 is also okay. And bulk density between 850 to 1000, 1100, depending upon the top charge system charge operations. So these are some of the vital parameters we talked about the blend. Uh, uh, the same thing I'm just trying to showcase based on our experience how these properties affecting the different properties of the coke. So the first graph showing the effect of dilatation or expansion on the coke M40. So we can see with increase in dilatation, there is an increase in M40 values, and then it becomes flat after 30 expansion of value of 30. So it is not very worthwhile to increase dilatation beyond a certain percentage, and also very high expansion values are not good for the battery health. Similarly, coal crushing finance, we can see with increasing the coal crushing finance, the M40, the coal strength increases actually. And we have also seen if it is going on the lower side, the M40 is getting affected actually, adversely affected. The same thing on the polarization or the crushing finance based on the literature. So we can skip this slide. Just one point on the coal part, I just want to emphasize actually. If we talk about the coal categorization, based on the different coals available in the market, we can divide the coal first in the tier 1 SSC coal with high CSR, roughly 68 plus kind of thing. Then we have tier 2 hard coking coals, which again divided into two different parts with low volatile around 18 to 20 or 23% kind of thing, and high volatile roughly around 25 to 28 kind of thing. With medium CSR, roughly between 55 to 60 CSR, we can say. Semi-soft coal, again, it can be divided into two parts, low volatile and mid volatile. Low volatile, it is around 20 to 24%, and mid volatile is a bit on the higher side. In fact, it should be high volatile, 30 plus. Although there are very less coal available in the semi-soft category with high volatile met. Its CSR is on the lower side, less than 50. Apart from that, weak SS coal is also very important actually. And this is the coal what we found across, at least we can see Tata Steel operations. Some of the plant are using very low and very high tier 1 hard coking coal, and um, some of the plant are not using at all actually. Although it is not making so much impact on the blend cost, with current scenario it can be different, but in general it doesn't make so much of difference. And these coals are very low CSR, less than 30 kind of thing. And the fifth category could be the non-coking coal. With it can be either one of the PCI coals, thermal coal, or any other coal with very low CSR, 10 to 20 kind of thing. And sixth category could be for, especially for Tata Steel perspective, could be the domestic coal, with CSR roughly 55 plus, 55 to 60 range, but very high as around 17 to 19% or 18.5% Right now we are operating, and blend VM, coal VM roughly around 22-24%, and CSN 3.5 to 5. Just one more thing on the blending part. What is in general the practice actually worldwide people are doing? Uh, so first, what we do try to do is the blend designing based on our past practices, or maybe some kind of modeling. So first step is to design the blend, and then testing the blend properties. So maybe a synthetic blend can be prepared and its properties can be tested. If it is as per our expectation and the requirement, then we can go to the pilot oven test and do few tests, and then try to get CSR, or the mean size or the M40 values based on the different type of pilot oven test available, starting with the 7 kg to 350 kg. And then if it is test results are okay, then the plant trial we can go. I think this is a general practice normally we try to follow. Now, if we talk about the performance parameter, how it is affecting the coke quality, we can see, especially in the COVID period and sometime in the monsoon period with the higher moisture, we always see there is the impact on the adverse impact on the coke quality when the moisture is in the higher side. But in case of COVID period, I think most of the coke plants went for a very higher CT period because of the less demand actually. So we can see here the M40 values has increased roughly around 82 to 84, roughly around 2 points increase, with almost we can say 5 to 7 extra CT actually in this period. And but at the same time, we can see CSR was hardly affected actually. It was more or less similar band, and this kind of fluctuation is a bit normal actually. Similarly, on the mean size part, we can see there is a significant increase actually. Normally, we operate around 46, 47 kind of thing, which has increased to 52 plus. There was some variation because of the, it is a kind of shift-wise data, so we can see some variation, but roughly around 4 to 5 points increase was visible actually. Apart from that, if we talk about the coke VM, that is also an important parameter to understand or which affect the coke quality, especially the coke strength. What we found in our case, we can see with higher the coke VM, the coke M40 is decreasing, which is basically indicating that improper carbonation or sufficient carbonation was not done. Heat input was not sufficient enough. It mainly happens mainly during the monsoon period, or maybe some gas changeover. And similarly, we can see on the right hand graph where we can see how the battery flue temperature affecting the mean size. So if we increase the battery flue temperature, the mean size is going to decrease. It mainly happens when we increase the battery flue temperature when the coking time is on the lower side. So where the demand for higher pushing, the coking time is going to decrease, so temperature has to increase. So the faster heat operating will impact the coke AMS, and it is going to on the lower side. The one of the things which in one of the batteries we are using is a gooseneck parameter. So gooseneck, we know it is basically at the gas collecting main, GC main, just at the start of the gas collecting main. We can say here this is a gooseneck thermocouple basically, and it measures the temperature of the outgoing gas which is going to the GC main. And this is quite helpful actually. And here we can see on the right hand side the profile of the gooseneck temperature, how it varies actually. So at the start of the charging, it is roughly around close to 550, 500, 550 kind of thing, and increases slightly on the at the almost at the end of the carbonization. And after the peak is reached, then it is going down. So this profile we found is very useful actually, and this profile is basically consists of two parts, part A and part B, and A plus B is nothing but overall cooking time, and part A we are saying is the time to reach the maximum temperature in the gooseneck, here gooseneck profile, and part B is the time post the peak gooseneck temperature. And this profile we found very useful in the sense the A and B separately also affecting the coke quality, and the ratio of is also impacting the quality. Uh, so these facilities available both at TSK and the TSJ in battery 1011. And here we can see impact of the part A, what was sorry, part B, which is basically the time post the peak gooseneck temperature. Here we can see with increasing this so it kind of soaking time, we can also say not exactly soaking time, so-called soaking time, there's an increase in CSR. And similarly on the right hand side we can see, which is more relevant because with increasing this soaking time, so-called soaking time, there's a decrease in VM, which is indicative of the completion of the carbonization time. There also we are trying to develop some models where we can restrict the cooking time to the extent possible actually. And because it's very difficult that you cannot do the cooking time variation shift wise. Shift wise maybe we can do, but oven to oven it is not possible. But it is very quite helpful parameter. Apart from that, there is one more parameter which we wanted to talk actually. It is the effect of screening parameters. I think top part may not be visible. So what we found, the coke quality, especially the mean size and M40, is also badly affected because of the way we do the screening of the coke. The first part, which on the left hand side, which I'm trying to show, is basically the screening, primary screening, which happens either at the coke planting or the uh, we call it raw material handling system. So at that end. So the first thing what we do, the coke from the coke plant comes either at the end of the coke plant or the RMHS, raw material handling system. There we screen it to remove the coke bridge, which is minus 16 millimeter normally, and then this plus 60 meter divided into different fractions, plus 70 and minus 70, because the this plus 70 goes to the blast furnace, and which basically feed the requirement of the center coke, because we know in the blast furnace we need center coke and surface coke, and this minus 70 goes at surface coke. So normally center coke size fraction is plus 40 or 40 to 45 millimeter based on different locations, and center surface coke is 34 to 38. Now this is very important apart from this center coke sizes, because this percentage also keeps on varying. So this also we are not able to understand that why for a given set of coke quality, how a blast furnace can change their center coke percentage. Sometimes what they do, they take from surface coke to center coke or center coke to surface coke just to make the balance of the requirement, but which is not the very right approach actually, because the inhomogeneity in the coke denominator will happen because of that. So that is something very challenging, because sometimes to maintain the mean level they have to do like that. And after this center coke and surface coke uh, goes into these two beads, then whatever minus 45 or minus 42 fraction, it comes here, and similarly surface coke minus 38 or 34 comes here, and divided into three different fractions. This is the first is the coke bridge minus 15 millimeter, minus 45 is the nut coke is 15 to 25, and surface coke, again out of these fractions, it is plus 25 goes back to one of the surface coke bead level. So this is the parameter which I was trying to indicate earlier. This circulating coke percentage, we getting this data continuously actually. And if this data is the value on the higher side, which varies between 20 to 25%, this is also indicative that fine generation is very, very high, and the blast furnace getting its impact immediately. And everybody get alerts actually, and then something has to be done here. It can happen because of the poor coke quality. It might happen because of the improper screening at the first place. So, what is the implication? One is the coke quality is going to be affected, and at the same time, if if the coke bridge and the nut coke removal is very much on the higher side, it is going to affect your BF and nut coke yield, and in turn, it is going to affect the overall cost per ton of hot metal, the coal cost per ton of hot metal. The one more thing which we are talking earlier, this is very much relevant. The coke drying system which we are using in our one of the blast furnaces actually, and where we are getting the coke from Haldia, and because of transportation, so on the way the coke moisture normally increases by 1 to 2%. So here we are using this system, and I think, as I mentioned, some of the coke plants also in India, other coke plants are using it. So basically, we use the cold blast at the exit of the coke bin, and temperature roughly 150 to 170 degrees centigrade. It reduces the coke moisture by 1 to 2%. So mainly used for Haldia coke, where the incoming moisture is high. And here we are trying to show the comparison. So we can see at Haldia, the dispatch coke moisture is roughly around 5%, and at Jamshedpur when it reaches, it is between 6 to 7%, we can say. And after this coke drying system, it goes down to roughly around 4 to 5.5%. So there is roughly coke moisture reduces by 30%, we can say, which in absolute terms will be roughly 1.5 to 2%. Similarly, in terms of the blend, the inert is also playing a big role actually. So we can see with increasing the blend, the inert percentage in the blend, which can vary between 2 to 10%, we can see that there is a drop in fluidity, which is not desirable, especially in this range, because normally we want around 200 GDPM. Similarly, if you see the CSR, CSR goes down drastically actually, especially beyond, we can say around even 1% also. So from CSR perspective, the addition of inert is not very much desirable, but sometimes we want to have a better mean size. So for that, normally people try to add inert actually. If we talk about the gas pressure, so from gas pressure perspective, we can see it is quite helpful actually. If it is allowed to use more of high gas pressure coal, and CSI is not a criteria actually, not a such a big constraint, then possibly we can add the coke bridge and overall system can be made more beneficial actually. And similarly, here we can see the additive addition in terms of the inert actually. Here also we can see with additive addition there is an increase in mean size, which is showed by the gray bars. So in terms of additives, we have one more which is very popular item, and I think some of the coke plants already worldwide using it, which is a pet coke actually, petroleum coke, which is mainly
I think Dr. Shankar got disconnected.
am I fine now?
Yeah,
I'm
but I
audible?
can't. But we can't see your
I
screen.
can't see the screen yet.
Okay. Now it is visible.
Yeah, it is visible again.
I think I'm pausing the time, so maybe is it okay, or I can do a little faster.
You can try and finish it
just
as
make
far.
a little
Yeah,
faster.
little faster. Yeah.
Okay. So pet coke is very lucrative because of the controlling the ash content, which is very low ash, around 0.6%, and the VM is also on the lower side. Uh, and but the major constraint using the pet coke is a very high sulfur, and especially the Indian pet coke available are very high sulfur, around 6%. But imported pet coke is less than 2%, so that can be used. Uh, but again, with use of pet coke, there is a drop in the CSR. That can be a constraint actually. Otherwise, we can use around 1 to 3%, which has been used at many locations. And this trial actually we took actually in one of our coke plants in Kalinganagar actually. So there we found there is improvement in the mean size. So if you go right from left actually, so there is an increase.
I think Dr. Shankar, your net connectivity is little, up, I would say not really good because there is a drop. Ankit, do you think it's a net connectivity issue?
Yeah, it's a connectivity problem for sure.
Yeah.
I think maybe we can wait a little bit for him to join back.
But he has disconnected. He is
Yes,
not connected.
from the meeting. Yeah.
Okay. Anyway, we'll come back to him whenever he's ready. In the meantime, let us move on to Mr. Deshpande. Mr. BP Deshpande is ex-managing director of Tata Sponge Iron Limited, which is now called Tata Steel Long Products Limited. Now, he is also, as he mentioned, he is representing Acre India, which is a Chinese player in the market. So, I'm sure he will have a few words to talk about Acre India as well. So over to you, Mr. Deshpande.
Thank you. Of course, today I'm not talking about the Acre India. I'm just talking about Coke Oven's experience as an operator and where the priorities currently stand and what is the current mindset of the people. This is mostly obvious for everybody. The point that I want to make here is that the level of emissions, point number 3, compares poorly with the other manufacturing processes. That is why coke ovens are typically under the focus as an environmentally degrading activity or environmentally degrading process. So once we understand this, that we have to come and match the environmental performance of the other processes within the steel plant or outside the steel plant, I think we have some kind of an intermediate target actually. I think the rest, the benzopyrens we had earlier looked at in a greater detail, so I don't need to talk about it. The other point which is relevant is, in India, the current level of coke production is about 40 million tons per annum. And it's likely to go up by about 15 million tons per annum by 2030. Therefore, there's a danger of more emissions or corresponding drop in emissions is required to be done. The climate change penalty issue has really not bothered us as yet, but it's, in my opinion, around the corner. I mean, by 2030 or so, it will start bothering us. And the penalties are pretty heavy, about 35 to 40 US dollars per ton, according to this study. I think Peter mentioned it is at 50 euros per ton in Europe. Maybe that is a little too much for us to start with, but it's going to be somewhere in this particular area. So these are the drivers as to why we need to look at the environmental issues, and the coke ovens operators need to stay focused on this aspect of the coke ovens operations. The solutions to the environmental problem, in my opinion, the technologies to arrest and collect emissions do exist. They are also applied in many places elsewhere. Their application at coke plants is often unwieldy and capital intensive. That is the only trouble. The capex cost for the environmental management issues exceeds 50 US dollars per ton of built up capacity. So this is the, let's say, hindrance as to why the managements are sometimes reluctant and sometimes the operators are reluctant to actually take the issues head on. The retrofitted solutions usually don't fit well, so it's good to actually have in the initial setting itself a good engineering for the environmental management. The activities that emit coke making also are mostly known to everybody. And so these are doors and leaks and whatnot. So we can let's just skip this. A technology for containing the pollutants are also known. I just try to put them together for people who want to look at one place. But there is nothing so very new to many of you in this particular slide. So if this is so, technology exists, technology is applied elsewhere, the pollutants are known. So what is the big deal in actually controlling the environmental emissions? So this is a low productivity of the ovens. That is one major issue. About 10,000 tons of output in a 450 cycles for any average Indian coke ovens. Maybe it's slightly different for the European plants or the more advanced areas. The capex of 350 US dollars per ton. So this is something which is a threatening number to the managements. When they want to invest for a new steel making facility, they see this as a major difficulty for them. So they would like to go around and see some shortcut solutions for putting up coke ovens. So that's one major dominant factor why many of the steel plants in India are not as let's say close to the environmental performance as in the advanced countries. The large number of points of emissions and therefore their collection. So, and this distributed collection, that makes it more difficult, that makes it more capital intensive. The points are scattered over hundreds of square meters. That's the other problem. Well, there are common sense issues. We just have to be sort of taking the stock, and maybe the technology needs to adapt to these kind of issues. So even during the operations, the points of escape that need attention are far too many, and there are multiple interfaces between machines and people. So therefore, the point that I comes to my mind is actually prudent to stop or minimize emission at source rather than deal with it later. So this, let's say, between the choice as a senior person in coke making operations, whether we should lay emphasis on controlling the coke emissions within the process, or whether we should handle it after it has emitted, this seems to be the trend, the obvious choice. The current state of application of technologies, particulate emission, is fairly well understood. So avoid openings to atmosphere, so continuous sprays, closed chutes, and things of that sort, closed ports, things of that sort. Secondary cleaning systems for dust, which is collected, is incineration or wet scrubbing kind of a process. And of course, you required the activity is also coagulating all this collected dust and reusing it back into the process, so that we don't have the problem of discarding where this material should go and it's getting emitted there. So these are the requirements for dust control. The SOX and NOx is about reducing at a generation for NOx. The technologies for multi-staging and air input is available now, widely practiced in India as well in the recent coke ovens. The H2S scrubbing and converting to elemental sulfur in the class process is also fairly in good stead in Indian plants now. For the downstream usage, the absorption and transformation to convert sulfur into non-hazardous disposable form by lime washing process. So this is something which is practiced. So this is the current state of application of technologies for SOX and NOx primarily. For carbon dioxide, there is, really speaking, not significant work being done on is in the pipeline either. The regenerators or drying or preheating using waste heat is something which is somewhat in vogue. Sequestration of carbon dioxide is not in vogue, not somewhere in the horizon also. The compensation for afforestation elsewhere is really speaking applicable in mining processes, coal mining processes or iron ore mining process, not so much for the emissions from coke ovens. For example, one tree reduces 20 kg of carbon dioxide per year. So correspondingly, we can say how much area needs to be afforested, etc. If one needs to compensate for the pollution that is caused by carbon dioxide. The recovery of waste heat as much as possible. CDQ is there. There are many other places where the waste heat is recovered. So it correspondingly reduces the additional CO2 which is potentially emitted to create that recovered heat. So that's the current state of technology in the operating plants in India at the moment. These are some of the examples, pictorial examples, where the NOx control, for example, by multi-stage air supply. This is not, let's say, unknown. This is just to put it together. The bleeders also, they generally emit NOx. So you require bleeders of a particular design. So you have to be mindful of choosing what kind of bleeders to use. So same principle, reduce the temperatures at the maximum temperature of the flame, you will get low NOx. This is the heat recovery coke ovens, or non-recovery coke ovens. When you put air through the oven top, usually there is a one hole in the conventional designs. Now this these are 4 holes to get the same amount of air, and the air is being directed not centrally to elsewhere. So this potentially has one big advantage, that it reduces the burning loss, brings down it from 3.5–4% level to 1.5–2% level by simply not letting the air reach the coke surface. So it just burns the volatile matter in the gaseous zone and does not allow the carbon or the coal carbon in the coke to burn. So contains the burning loss and thereby reduces the emission, carbon dioxide emission. This is a new design for door sealing or the contacts between the silica and the structurals as to how it can be done better. So their technologies are available. They are primarily German, Chinese, both technologies are available. The other tendency that we are also following in India now is to go to higher capacity coke ovens. So just to sort of get 90 cubic meter size ovens are available, whereas in India currently even 25 cubic meter size ovens are also in operations. So as we upgrade our coke ovens, we need to get there, especially the new 15 million ton capacity which is going to come. The closer we go to the 90 cubic meter size ovens, the better we are in terms of environmental emission. This is the next example of how the emission can be contained, actually speaking. These are these valves at the oven top, whereby you actually control the pressure inside the ovens, and thereby don't allow the oven contents to leak out the door gaps or door leaks, and thereby you can actually contain the emissions at the source. So these technologies are available to a certain extent in practice. The larger trend that seems to be prevailing in India is to actually head towards lower coke rate, which is also very logical. Cost comes down, emissions come down, and everything. So that's something which is actually getting there. Beers that cannot reduce coke rate, there are quite a few small capacity blast furnaces. So they tend to become uncompetitive, especially when you attract carbon tax in the coming times. And once they start doing that, they have no other option but to upgrade themselves to higher capacity ovens, close down the operations. So the coke oven operators have to give precedence to emission control, containment of emission rather than subsequent management of the emission. The new coke ovens will have to get in larger in volume. So the engineering has to support this. And the coke oven shell, English perspective, would get into league of other clean manufacturing processes. So once we get here, to my mind, then the pressure on the coke makers on emission control, etc., would come down. This is what that I wanted to just really summarize and sort of communicate as to what is the current state of environmental management, what needs to happen, what is currently happening. Thanks a lot.
Thank you, Mr. Deshpande. Thank you, Mr. Deshpande. I think you took us through the journey and what needs to be done, what is happening, what are the environmental challenges that we are facing today, and what is likely to come in the days to come. Thank you once again, and I'm sure once you get involved more into ACRE India, we'll have more interactions in future.
Yes.
And I will keep in touch with you.
I would love to get them to speak actually what they're doing, etc. Rather than my speaking.
So I'm sure under your guidance, ACRE will have a strong footprint in India in the days to come. And as Mr. V.R. Sharma mentioned, the days of coke ovens are not over. The days of blast furnaces are also not over. Though the new generation, Dr. Mukesh Kumar and Mr. Subrata Mitra will also agree that maybe in the days to come, we will not have too many blast furnaces coming up. There won't be too many people building blast furnaces. But then we cannot do away with the blast furnaces altogether. So I think the challenges will remain, but blast furnaces will survive. You know, if you look at China, for example, China, if you are putting up, let's say, a DRI-EAF plant, it can only replace a blast furnace. You know, they do it in such a way you cannot add capacity. You can only shut down a blast furnace and put up an electric arc furnace steel making in its place. I mean, but you cannot overnight throw away the blast furnaces which existed for donkey's years, for so many years, and which has contributed so much to the economy. So the challenges will remain, but we have to make ourselves more and more lean, more and more efficient to tide over this crisis. With that, I'll come to my good friend Onrin. Onrin research work primarily even during his PhD on this subject. So I'm sure Onrin will have quite a lot to share with us. Onrin, the floor is yours.
Thank you. Can you see?
But nothing is on the screen.
My screen.
Your screen is being shared, but your screen is blank. Yeah, now it's okay.
All right, great. So first of all, it's good to see still some people are there, and I believe the people who are still there are really, really passionate about the coke industry. And this is something, coke and coal is something, as we had the discussion with Mr. Sharma and Peter a couple of minutes ago. Blast furnace and coke making will surely reign at least 50 years because things couldn't be changed overnight. And I always think in this way that the countries who are having an excellent growth rate, like Vietnam or those other Southeast Asian countries, now, if they will require more and more capacities, and if you have a look, I was just reading a report from Argus Coal. They said that the coking coal demand in Vietnam will increase by threefolds from 2.5 million tons per annum to 7.5 million tons per annum by the end of 2030. So having said that, just a couple of things about our company. Some know us, some don't. So we are a very small and new company. We started in 2018 with some other activities in the recycling industry in the heart of Austria. And also, very importantly, why I'm here is the reason that at the time of my PhD, I did my PhD with the samples of voestalpine cokes from Linz. And there are two plants of voestalpine in Austria, Linz and Donawitz. Linz have their own coke oven, Donawitz doesn't. So Donawitz exports all of its coke from the standalone coking plants in Poland and Czech Republic, which is a very interesting business model and logistics supply chain they have. Now, checking back to this picture that we had from the one of the publications of the European Union a couple of years back, you can see that this is a very interesting graph putting one-sided economic importance and the other side is supply risk. So here you can see coking coal from the side of supply risk is not very high, but very, very high economic importance. And that's why under the EU norms, coking coal is considered as a critical raw material. So all the elements inside all the material inside this red box are critical raw materials designated by the EU. And why coking coal is so important? Because if you think about the OPEX, 60%, 50 to 60% almost of the hot metal OPEX is coke, and 1/3 of an integrated steel plant is coke. So just a couple of points which I'd like to touch today, not in very detail. So problems of the Indian coking industry, challenges related to the coke properties and technologies and policies which may help the industry, because there are certain things in India you can do but also still cannot. So implementing certain things may also be viable in the future. Also, briquetting of coke breeze for alternative cupola fuel. This is something very interesting that we have come up in the last year. We will discuss it. And also sourcing diversification. So some, not all, just some problems of the Indian coking industry is, of course, that we know that India is full of really, really, really bad quality coal. So it is not available nearby. Also, under Indian circumstances, the blend that is produced in India has a relatively high ash content compared to other parts of the world. And also the coke consumption is high because of the higher alumina content. There are certain limitations about the additives, what you can and cannot add in India. Of course, very important is the cost management of the blend. And the last one is sourcing. So since India is very, very highly dependent on external sourcing, so this is a challenge, and always you have to keep on diversification of the sourcing of your sources to cater with the challenges, because so far people try to put all the baskets in the egg, which is called Australia. But however, right now I can see certain sourcing diversifications, but there are other possibilities. So first of all, CMC and CDQ, coke moisture control and coke dry quenching. These are the things which, of course, increase the coke quality in the final way. As my very good friend Koji Saito said, I have seen their plants in Hokkaido, I have seen their plant in Futsu, and it's a delight to see all the additional equipment related to this, which is running in terms of these other processes. The second one is, of course, blend optimization. And when I say about optimization, it means using more and more elements other than non-prime coking coals in the blend, so that your coking properties do not suffer much. But however, the cost of the blend also gets really, really reduced. You need more flexibility about additives, what you can add, and diversification of the industry to sourcing countries. This is something which I personally have this lesson from, especially working with Donowitz. They don't have their own coke oven, but they import all the coke from Poland. And not only Poland, there are other possibilities in the whole world that I will touch upon later. Now, what we have done in this field so far. So our company, and also back in the days, I was also doing my PhD, which I implied in the industrial work, is certain advanced characterization methods of finding out how the coke actually behaves in the blast furnace, and to make a forecast how it will use, or thinking about its properties. Then the second thing is blend optimization for high CRI, high CSR combination. Now, this is actually a paradox, because from our convention, from our experience, we know that if a coke has high CRI, it will have less CSR. However, there are very, very few cokes in this whole world, coking coals in this whole world, which show this peculiar tendency. One of the best example is the Australian Curragh, CURRAG. So if you're talking about Goonyella pig downs, yes, there's prime material for your coking blend. But if you think about Curragh, this is one of the most peculiar coal, which shows high CRI, high CSR combination. And using our characterization methods, we find out certain ways why it reacts and it behaves in that way. And this technology is actually possible to change the structure of your existing coal blend and try to find out how to increase the CRI as well as CSR. Because if your coke is highly reactive and it has high strength, it is best for all. The third, which is the people in India don't like, is pet coke. But being in Europe, we have seen 10 to 12% pet coke in the blend. And pet coke is very good, especially, I mean, when I say pet coke, that means green pet coke. And if you have lower sulfur pet coke, it will reduce the cost of the blend heavily. And the third thing, we worked a little bit with the German recycling industry, is trying to incorporate plastic in the blend, the waste plastic. So it works very well in the countries where you have a good waste separation technology from the waste separation process, starting from the domestic waste separation, and using 1 to 1.5% plastic maximum in the blend will save you a lot. I have also been involved into a project in Ukraine in a plant near Dnipropetrovsk. They had a huge sawing mill nearby, and they tried to incorporate sawdust, 1.5 to 1% into their coke blend. However, it didn't work very well. As you all know, one of the biggest enemies of the coke or the blast furnace is high alkaline content, sodium and potassium. So they usually destroy the structure of your raw materials. That was the problem with the sawdust. That was quite high with sodium and potassium because it comes from an organic material. So it didn't work very well. However, these are the additives which could theoretically work. In certain cases, especially plastic can work very well. And there are other elements from the biomass, like one of the plants in SSAB in Rautaruukki. They also try to use a certain percentage of biomass. This is something we were not involved. I just have good colleagues, so I know from them. That's why they tried to use. Now, just some aspects that how deep you can visualize coke. So here we had two very different types of coke lumps, the left one and the right one from Poland and one from a Hungarian coke oven. And actually, when people get ill and they undergo computer tomography, a CT scan, we tried to understand the porous structure, the material, the ash, the structure inside the coke using CT scan, and took very, very different coke structures nearby. And it will be very interesting to see that how the coke look under CT scan. So it is just like in the same way, it is very simple. You have the coke piece and you are scanning from one angle, here from the top and here from the front. So you will see how the structures appear. The very bright ones are the ash content, alumina silica agglomerates. And here you can see very slowly how the structures appear. And if you look at very interestingly, the one in the left, which is a Polish coal, and the one in the right, which is a Hungarian foundry coke, they have very, very different porous structure, and that's why they have very different properties. The left one has very, very high CSR. The right one is low CSR coke, but that's how you can visualize how your coke looks like and how it may work during the process operation. So I will not go for the scientific things long because there are more things. Yeah. So one proposal came to our company from Chelyabinsk in Russia, which is very interesting. So in Russia, there are lots of coking plants which produce a huge amount of coke breeze. Now, coke breeze is something that you get in Russia as a waste and much, much cheaper than international price. So what they do, they send their coke breeze either to Poland and Ukraine, and they have certain briquetting technologies, which which is a little bit primitive technology, but we also worked on this, and we are better binders. And this, they sent it back to Russia. Now the Russians, they wanted us to do this work there. However, we had to travel there. We couldn't do because of the corona problem from last year. This project is still in our open book. So whenever the travel restrictions are lifted, we will go and start. And this coke breeze could be used as an alternative cupola fuel. This is not that tough to use in a blast furnace. However, the countries which still have active cupolas, like Russia, Ukraine, India, even China, this might be a very, very good solution to replace a part of the foundry coke using briquetted coke breeze. And finally, this is something we are very active right now in to diversify sourcing. So apart from your standard names in Canada, Canada, America, and Australia, there are 3 key players for the future, as you all know: Colombia, Ukraine, and Russia. And we have partnered with Colombian and Ukrainian coke and coal industry. And very interestingly, if you see here, this is from February. We had been to a delegation trip in Colombia to make this partnership. This is something you will never find anywhere in the world other than Colombia. Maybe a couple of countries in Russia still running, I'm not sure. But this is the so-called beehive coke oven. Very primitive technology, but it still works. It's like that, and they are very nearly located to the ports. So they produce their coke oven, coke in there, and supply to all other parts in the world. Now, very interestingly, they're always open, to have more capex and upgrade their coke oven to better coke ovens. And this is something I was also thinking for a long time in terms of business feasibility, that if your country has some problems with land, some problem with pollution aspects, it is always good to make smaller coke ovens in the countries of your source, which don't have the strong regulations, make the coke there and ship your coke using Handymax or one step upper than Handymax. I think Handymax or Panamax vessel, maximum 50,000 tons per vessel. So that's how you can get the coke you want. You can diversify your source, and you can try to manage your sourcing problem if you need coke in a high volume. This is something, a business model we are thinking with our partners. So it all comes down to a new way of thinking, how we can change the whole scenario in terms of both technological and financial and economic point of view. So one thing I just remember, if you know about the German poet Wolfgang Goethe once said that new ideas are like chess pieces moving forward. You can eliminate them, you can capture them, but they may start a new winning game. So all the time, new ideas and new sourcing methods would be very interesting to put in an age-old industry. And of course, if there are questions in more detail, I'd be happy to take that. But thank you very much, Mr. Mukherjee, to bring out the topic of coke and coal right now, because in the world right now, which is crazy about green things and trying to make everything green, and if people say I'm trying to make green, I always call them, buy some green paint and paint your blast furnace with green so that you can have a green blast furnace process. However, we still have to work with coke and coal as long as there is no feasible process and we cannot deny coke and coal from our life and the steel industry. Thank you.
Thank you, Andrin. I think the first person who wouldn't agree more with you is Mr. V.R. Sharma and Peter as well. So both of them will obviously have a lot of, I would say, admiration for your point of view. Having said that, let us also agree that we can do so many things to reduce our carbon footprint.
Exactly.
And let us not blame coal, because it has remained as a major source of energy for us for so many years, and we cannot do away with that, especially for, let's say, a resource-rich country like ours, where it is also an employment generator. It feeds a large section of our population, and it is a ready source of energy. It is a source of energy which is readily available with us. So thank you, Andrin. Thank you for your point of view and your thoughts on producing perhaps coke in countries where the laws are not that stringent, where you still have, I would say, room to play with.
Yeah.
So with that,
I know some producers who every month exports, Indian steel producers who import approximately 50,000 tons of coke, not coking coal, but coke from Colombia. So this is a very interesting business model, and the feasibility study will only lead into profit. So this is something more Indian companies may consider, in my opinion.
Yes, our ICVL, Indian Coal Ventures Limited, ICVL was formed primarily to scout for coke, coking coal, rather than sourcing the coke right away. So instead of looking for captive mines, we could look for, let's say, coke oven plants, or build up smaller plants.
And the countries like Colombia, they're very, very accommodating in terms of FDI. So if you go with them, you tell them, I can lease your coking coal mine. One very important thing is the Colombian coking coal is the ultra low phosphorus coking coal. So 0.005% phosphorus is in there. So if you can make little bit better standalone coke ovens there, the companies which can make them captive and use that coke to make steel in India, that will be much profitable. That will give you faster ROI than importing Australian coal and making standard coke oven in India.
Agreed. Thank you, Andrin, once again. So with that, we'll move on to the last presentation of the day, which is Mr. Bidyut Das, who's principal researcher, coal and coke making group of Tata Steel again. So over to you, Mr. Das.
I hope you all can see my slides and can hear me well here.
Yes, we can. Please go ahead.
Yeah. So thank you for this opportunity, and I'd like, maybe it's just a coincidental that I have chosen this topic for this webinar today, which Dr. Kumar has highlighted in the beginning, that it does the stem sizing technology out of all the recovery, non-recovery, this conundrum, and whatever is driving these world of coke makers to decide on the technologies. I think this stem sizing technology is the technology to go with as far as the country like India is concerned, where we have a lot of resources, a lot of optimization is still possible, a lot of mines needs to be scouted and looked for, and a lot of coal reserves here yet to be explored by the coke manufacturers of India. So this is slide I'll be putting, or maybe I'll be echoing slightly what Dr. Kumar has highlighted in his brief presentation, that the stem sizing technology is the way forward in utilization of the coals which is available in India. But partly I also park some of the contradiction, some of the controversy, rather, that whether this is the right selection of technology if we want to use these Indian non-coking coals because of their notorious of ash levels, difficult to wash, difficult to get rid of the sulfur, because the coals, which is in tertiary in nature in some part of eastern India, which is Assam, are having so much of sulfur that the question is not that how to use this coal. Rather, the question becomes is, should we mine this coal, because this can damage the whole ecosystem of the surrounding people living in this area, and so and so. So with this, I'd like to start my presentation with echoing Dr. Kumar's slide that anywhere in the steel plant, the heart of the steel plant is, from my personal view, is the blast furnace, because this is where we produce the hot metal. And as far as the country like India is concerned, and given its growth story that it has picked the momentum lately, the steel industry, these blast furnaces are going to be with us for a very, very long time to come. Whether you do it with hydrogen, whether you do it in natural gas, we do some things or other with this blast furnace, but blast furnace as a whole will be there, and it has to be there for the country of India, like to sustain and meet the demand of India as far as the steel per capita consumption is there, and maybe for the whole world to come. And these blast furnaces need certain raw materials, as all the speakers have mentioned, and the focus of today's discussion is the coke. And the coke, since it's been produced from the coals all around the world, it drives the cost of the hot metal. So if you look at the very typical, cost of the hot metal, so 45 to 50% around the cost of the crude steel, in a very loose translation, is impacted or is driven by the cost of the coal. Sorry. So any hot metal or blast furnace operator who actually wants to produce sustainable hot metal at a cheaper cost, so they have to first attack these production of coke, and they have to scout for cheaper coals, whether in India or in abroad, and they have to first blend it, and then they have to take it to the coke making route. So the first conundrum, the first form of utilization of the coal to produce coke with the coke oven comes from in the form of mixing or blending different sources around the world of different categories, different properties, and end up in a blend, end up in a mixture, so that we can produce the desired quality of coke. As Dr. Shankar has highlighted in his slide, that we have a very strict and very specific need of coke properties to be used in our blast furnaces, and for some reason or other, these is not in agreement with other countries. So if you move to Europe, their way of picking the coals, picking the coke, may be slightly different from us. So one way or other, we are bound by our blast furnace operators who demands that these specific set of properties has to be met by these coals or the coal blend you have chosen at the end of the day. So there should be always a balance between CSR and CRI. Though one of the last speaker highlighted that he has some curious case of where coal from Kara, which we have used in past in Tata Steel, that have high CRI and high CSR, but they do not always need the blast furnace, because they can do some funny business inside the blast furnace, and if you are not sure what we are doing, then the whole operation can go for a toss. So the whole conundrum lies that where from to get these different categories of coal, and how to mix them, and then how to get a coke which is being approved by these blast furnaces, so then they can sustain this blast furnace operation as far as the operation is concerned, as far as the economy of production of the hot metal is concerned. So this is where you could see that the Tata Steel, though it has its own captive mines, though it is using a larger amount of maybe captive mines in its plant, we are still using 30% around. So this is a typical figure. This is not very accurate in that sense. So 30% of coal we are still importing from the countries like Australia. And there goes the saying that if the Queensland catches coal, the India starts seizing. So this is where these metaphors started, that because of the heavy dependence of our plant, heavy dependence of other integrated steel manufacturers in India in a specific geography, so that the whole coal is supplied by one or two specific geographies. So even if we have our captive mines, you could see that our non-coking coal or lean coal utilization is limited. Even if we have a technology called stem cells technology of coke making, which is being primarily adopted to increase these non-coking coal or inferior coking coal percentage to more and more, but we could soon realize that there's a theoretical limit of using non-coking coal with the adoption with this technology. It means there's a virtual ceiling, a virtual barrier which you cannot penetrate and go up unless we do something very drastic, very dramatic, rather revolutionize these technology of coke making, of whether it's by stem cells in coke making or all. So you could see that, as Dr. Kumar has highlighted in the figures, that we are fortunate or unfortunate with coals, which is primarily termed as non-coking and inferior, which is primarily being used in the power by the power industry, and this is needed also for a country like India, because we are a growing country, and if the kitty of this coal is being transferred to coke manufacturers, whether this will be a fair idea to the power-hungry country like India or not, so that has to be debated separately. But this unique unfortunately that we do not have so much of coking coals, good coking coals or medium coking coals, leave us with a possibility, leave us with a scope of innovation that we must do, because this innovation we cannot expect from some other countries. So it has to originate, this has to come from India and the Indian steel makers collectively, to go and look for ideas, to churn our fertile minds that we should look for ideas, we should invest in the ideas, the technologies, the R&D, so that we can utilize more and more of these non-coking coal, so that we can cut the dependency on the coal producers like Australia and all, and we can immune ourselves from the volatility of the coal market. So with that, just to give you a brief idea of that, how the coal converts to coke, and this is not a technical slide, so I just highlight the point that to convert this coal to coke effectively and efficiently, and to introduce more and more of indigenous coal, probably being the main drivers for this technology selection, Tata Steel has selected long back, and they have now kind of adopted the stem charging technology of coal making and reshaped, remolded in its own terms, and gained these huge amount of experiences in running this stem charging technology with indigenous coals. And you have drastically come down our prime hard coking coal used with the help of this technology, but we are not to the mark of zero yet. So our target will be to go with a complete free of prime hard coking coal in the blend with the same technology. But this is not going to be possible without a further innovation in the down the line of the carbonation process. So this stem charging technology is effective and efficient technology of compacting different coals from different sources with some prime hard coking coals, some hard coking coals, and some inferior coking coals, but with a certain limitation, as I had mentioned before. It cannot penetrate that barrier, the upper barrier yet. We are not zero of prime hard coking coal yet. So there has to be some transformation, some radical innovation must be there in the downstream of this carbonation process, where we innovate, we invest in R&D, and we produce a technology where we plug in this technology with the existing coke making technology of stem charging coke making technology, and we end up in a process altogether which can use our indigenous non-coking coals to the maximum extent percentage possible to cut down the dependency on the prime hard coking coal completely. Scope 91, as as one of the speaker has mentioned, that can be a solution, but I assume they are capex intensive. So any process, any R&D process which is a capex intensive will be always unattractive at first, maybe for the adaptation, larger adaptation by the different coke manufacturers. So the idea has to be less capex intensive, and it has to be a plug and play kind of thing, because if you can look at the top charge to stem charge kind of this translation or this transformation or evolution, it happened and it's been adopted quickly by at least by Tata Steel, because of the simplicity in the problem. And one of the speakers has mentioned that many complex problems has to be solved with simple solutions rather than going into more complex kind of approach. So there, I believe personally that in this zone of carbonation process, not only in the blending part, not only in the coal selection part, lies an immense possibility of blending. And this is where I think the Indian steel manufacturers has to come collaborate and look for a collective solution there. So why again reiterating the fact that the stem sizing has become popular with the Tata Steel because of its availability of captive coals? Yes, that's one of the reasons that why Tata Steel went for this technology at first, because it has hold of these mines like West Bokaro and Sharia, of course, but also the key benefit is that the stem sizing technology can have more throughput per oven. It can introduce more kind of inferior coals in the plants because of the virtue of this compaction technique. And obviously, it ends up in a better coke properties vis-a-vis with a very high proportion of inferior coals. But I believe that this is not the end, just the beginning, where we should innovate. We should keep innovate. We should keep running our minds, invest in the R&D, so that we can have more and more solutions coming out of these existing technology, which is easy to implement, easy to adopt, so that we can solve the problem of using more and more indigenous non-coking coal. But having said that, for the indigenous non-coking coal, another stream which needs to be parallelly developed or parallelly innovate is the process where we would get more of yield from these non-coking coal at a very attractive ash level, because an ash level which is 15 or 16% with a yield of even a poor yield of 20 or 30% will not be attractive at all. And then the obvious tendency for the coal industry will be to shift these products completely towards the power industry will remain. So unless there is a paradigm shift in terms of the R&D is happening in the beneficiation part, it is not likely to see a certain growth as far as the non-coking coal using or inferior coal using coke making process is concerned. And that's where lead to the second conundrum is that even if we have and perfected this coke making technology of stem sizing, it is also not immune to this challenge of making a perfect blend each coal. So just to meet the demand of the blast furnace, it means suppose I say that the coke strength has to be a certain value, let's say 65. It means that without doing much of technology modifications, with efficient coal processes, we have to have obtained always a good coke with low grade coal. So this is a sort of paradoxical situation for the coke manufacturers, which I think the coke manufacturers, the coal blend designers solve every day, every time they introduce a new coal in an anticipation that the coal blend cost will be reduced or the coke properties will get enhanced. But this process will simply get more complex once we start introducing our high ash Indian coals, because there will be a lot of resistance from the blast furnace people. If the coke ash started just simply going off, then people will simply not adopt these products and not accept this product rather. So though the stem sizing technology is a proven technology, I think it has still not matured enough. It is still not matured enough. It's still in the bit of this learning curve for the whole coke manufacturer, the whole coke fraternity is concerned. That if we still want to reduce this expensive hard coking coal part and introduce more of this lean part, I think there is some insufficiency, gray areas remain in this stem cell coke making technology, which needs to be solved maybe ingenuinely and maybe more innovative approaches required here, so that we can reduce the coal blend cost without compromise on the coke properties. So to sum up my presentation, India has huge amount of non-coking and inferior coals, which is now established in this discussion. It's available already, but there's the lack of the approach, lack of these innovation in the beneficiation part, so that these kind of lacking makes this product still unattractive for this coke manufacturer. So here lies the huge opportunity, huge market probably for investing in this. Again, stem sizing technology, though it has started adopting by different coke manufacturers, it's yet to get matured, in this level that we could push more and more non-coking coal, and we can push the envelope further of using completely free of prime hard coking coal blend in the stem sizing technology. But that is yet to come. Steel manufacturers, integrated steel manufacturers primarily, should get immune to these volatility of the market, which one of the speakers again highlighted. Maybe that's a very basic reason of going into and developing the scope 21. So we should also focus the steel conglomerates all around India should focus, collaborate to produce maybe next scope 21 for India, and we should see and we should push for more sorts of collaboration so that we can use our own raw materials, our own coals, which is obviously cheaper, without disrupting this power industry, and to cut down these dependencies on these foreign markets and once for and all. So with this, I'd like to conclude my presentation through the acknowledgement of my management, Tata Steel management, who has given me this opportunity to present my views on this STEM charge technology, and also to the organizers of this webinar to give me this opportunity to share my views on this old but effective STEM charging coke making technology. Yeah, thank you.
Thank you so much, Mr. Das. Thank you, Mr. Vidyut Das. Mr. Vidyut Das is the principal researcher for coal and coke making group at Tata Steel. And the stamp charging, as we all know, the pioneer for stamp charging in India was Tata Steel. There's no second thought. I think Subrata would also agree with me that stamp charging, the pioneer for stamp charging is Tata Steel in India.
Yes, of course. And Mr. Deshpande is sitting there, so he's party to it. Tata Steel is pioneer.
Dr. Mukesh Kumar, you did mention stamp charging during your presentation. What is your thoughts on this?
Because what we just wanted to tell only, because our demand is growing, and today we don't have any other alternative other than blast furnace to meet our requirement for next 20 years, because we have to build for technology. So in my opinion, if somebody is saying that blast furnace may not come much, but there is no other technology also available, because we don't have gas, we don't have other things. As far as the stamp charge is concerned, because this is the only probable solution presently available, because continuous coke making like scope 21 and other things, I don't know why those could not come till now. But looking into the present circumstances, other than stamp charge, I don't see any other alternative which is giving a better option, because it is the only coal, it is the only technology which can allow to use our indigenous coal and minimize our dependency on imported coal.
Thank you, Mukesh Kumar sir. Thank you so much. With that, we come to the end of today's session. We were supposed to finish at 6:40, but we are finishing at almost 7:40. So that would mean a delay of 1 hour. Anyway, as they say, better late than never. So we were a little late, but it is impolite. I always keep saying it is impolite on my part to keep someone, when he is speaking, to cut him down, because first of all, you are not sort of giving the regards and respect to the efforts he has put in behind preparing this presentation. There is a lot of effort which is required in collating the information together to give a presentation. So having kept that in mind, it's a knowledge sharing platform where interaction between panelists is also important. So that is why I think, to do justice to the subject, you may extend the time a little bit, but make sure it's a fruitful discussion at the end of the day. And as the discussion was going on, I was getting a lot of messages that people found today's platform, very interesting. So thanks to everyone who are there on YouTube or Facebook or on Zoom to attend this webinar today. My thanks to everyone, including the panelists, my chairman, Mr. Subrata Mitra, Mukesh Kumar ji, Andrin, my good friend, and everyone, including Peter, Mr. V.R. Sharma, Mr. Deshpande, Dr. Maya from Veta Technology, to everyone who have made it a point to address and listen to this webinar today. Over to you, Subrata, for your summing up and final comments.
Thank you, Nirmalo. Today's deliberations were of very high quality on the most important subject of coal and coke. We start with, because Mr. Sharma joined a little late, but since he was a keynote speaker, I should give his, whatever he spoke about first. He informed us, the whole house, that JSPL, Angul, is the first plant, perhaps, yes, it's the first plant using coke oven gas for DRI making. That's a big achievement, and they have successfully utilized coke oven gas for DR making and for melting the DR in the existing electric arc furnace. So use of coke oven gas is also spoke about blending of coke oven gas and syngas also in certain cases. Spoke on coal blends, how to use coke oven gas for various other uses, coke oven byproducts. He also shared thing that methanol production is not economically, although it helps in reducing the petroleum consumption, but it's not economically very attractive. And seeing the success of using coke oven gas in DRI making, second DR plant is being set up at Angul. So Mr. Sharma, as usual, with his vast experience, shared his lot of views in this regard. And he was a big champion, of course. Most of us are using coal for years to come. It's not going away. Coal is an asset which India has, and we have to utilize it effectively. Then Mr. Dr. Mukesh Kumar of ASA TMI, he was the first speaker. He, as his normal, his knowledgeable knowledge sharing, he informed that 45% of iron making cost, we all know, are for using statistics of, because that comes from the coke cost. He talks about the expansion of steel industry in India will require a lot of coke and in turn a lot of coal. We have limited coking coal reserves, but coking coal needs to be imported. He gave figures for domestic availability of coking coal. The ash reduction of coking coal is an issue which needs to be taken up for economic use of coke. He spoke on heat recovery versus stamp charge recovery coke ovens. High capacity ovens, 6 meter or 7 meter tall, will improve the performance of the coke oven as well as reduce the operating cost. He briefly touched upon scope 21. And Dr. Koji Saito of Nippon Steel R&D spoke in details on the scope 21. Actually, that for building up super coke oven, continuous coke making, and also highlighted the coking coal supply demand trend scenario. Coal moisture control is being practiced in Japan. Pilot plant, we talked about pilot plant setting up, they have set up in Nagoya plants and the operating results on the coal blends. Then the next speaker was Mr. Peter Rizzo of ThyssenKrupp. He was very emphatic on continuing use of coal since in Germany, a lot of lobbying is happening to stop use of coal in all sectors. But he rightly pointed out that without coal, iron and steel cannot be made for years to come. He presented the Schwelgon coke oven plant, which has 2 batteries of 70 ovens. 24.6 is the coking time, 24.6 hours, 130 pushings per day. Throughput is 10,600 tons per day. So he spoke about elaborate pollution control measures in German, as per German standard, which has come down to 70 nanogram per meter cube from 5,000 nanogram per meter cube. The pollution level is being monitored as per BAP emission values. The ambient working conditions has to be less than 3 PMI. His presentation was very elaborately described environment control in coke ovens. And the next speaker, Dr. Thiago Maia of Metatech, Brazil, spoke on the energy and sustainability digitization which is being carried out. The interesting topic was the gas. He discussed the energy flow simulations for effective use of gas for various applications, which in turn reduces operating cost and effective in productivity increase. The gas mixing ratio is fine-tuned. This is done through gas dispatch optimizer to restrict carbon footprint, to conserve electricity, to reduce gas flaring. The payback effect, the payback for all this digitization initiative is very fast, in less than a year. Next speaker was Shri Amitabh Shankar, head coal coke process technology, Tata Steel. He spoke on the enablers for better coke quality, maintaining the informed about the CSR values and M40 values that is being maintained. He spoke on TSL, operation like coke ash control, moisture control, and coal blending. Coal categorization is done, coal blend practices, for which testing is done for blend to find out blend properties, to check the CSR and M40 values before putting in use. The effect of process parameters were discussed, and coke moisture drying at Jamshedpur from the Haldia oven, how much moisture is being controlled after coming to Jamshedpur is also discussed. After drying, 5 to 7% moisture comes down from the starting Haldia starting of 15%. That's a good effect. Next speaker was Mr. Deshpande, ex-Tata Steel, and now with Acri, of course, he spoke on, shared his coke oven operation experience, the level of emission which are in focus here, focus internationally. The climate change penalty issue is touched upon, which has still not come into action in India yet, but that will be coming. So solutions of environment control has to be found out. Solutions are costly, but some mechanism has to be found out to do it. Low productivity is a major issue for coke oven productivity. Now he had as his idea was to stop emission at source, such as door leakage, reducing the number of pushings, door opening for pushing. These are the talks and necessity to control SOx, SOx, and NOx. Higher capacity coke oven will reduce some of the pollution control, pollution emission issues, and also increase the productivity. Pressure control to control emission is also vitally important. Now, and the attempt has to be made for lower coke rate, of course. Dr. Andrin Bhattacharya of Recreon spoke on the outlook of Indian coke industry, and he suggested that coke can be procured. Sourcing of coke is a challenge. It directly, coal can be procured, coal is being procured, but Indian companies can also procure coke directly from countries like Colombia. And he spoke on the company share and the graph showing what are the benefits they apprehend and they have in mind for coke moisture control, coke dry quenching, blend optimization, more flexibility on additive from the sourcing of coke, and spoke on CT scan analysis to find out the ash content. He compared the Polish coal and I think Czech coal. Mr. Vidyut Das from Tata Steel spoke on stamp charging benefits. What is being happened, the good point was the stamp charging has reduced Tata Steel's dependence on use of prime. The whole issue is how to reduce the use of prime hard coking coal by stamp charging, which is definitely profitable, and that should be the future planning aspect, because India is short of prime hard coking coal. Spoke on coal to coke, effectively conversion of coal to coke conversion. So in short, the discussions were on very high level and real technical thoughts were shared, and according to me is really a lot of things that have been shared for the benefit of the industry. Thank you.
thank you, Subrata, for once again elaborately summarizing today's proceedings so very well. And content-wise, let me also accept that the content-wise we had rich content today. There was no, the content was really impressive. This was what we were all looking for. And my, I would say my gratitude to Andrin also, who helped me along with Mr. Subrata Mitra, along with Subrata. Andrin was one who also helped me a lot during this entire, organization part right from the beginning.
Thank you.
So with, so thank you, Andrin. And before we close and Ankit proposes a vote of thanks, let me just highlight the next webinar, which I had initially planned actually 3 webinars during this month, but rightly so, my chairman, Mr. Subrata Mitra, pointed out that this is very difficult time. For 3 webinars, we may not even get 30 people. So keeping that in mind, that it is very difficult time, we discussed and reached a conclusion that we will keep it to 1 right now, which is on technology, market, and application for rebars and wire rods. So for rebars and wire rods, technology, market, and application on the 21st of May, 2021. That's the next webinar. Ankit, please keep a note of it so that we get working on it from tomorrow to organize the panelists for the next webinar. Technology, market, and application for rebars and wire rod mills. So that is the next webinar. Then moving forward, next month we'll do something on iron making. And also there is something which I'm interested in doing, which is on water treatment plants and water as an essential raw material in steel making. So this is something I have in mind. We'll implement sometime during next month or in the month of July, depending on the pandemic situation, how bad it is, and when we get the 3rd wave, things are getting worse day to day. And Peter will agree that the 3rd wave in Germany is already in. We already have the 3rd wave in Germany, and we are at least 2 to 3 months behind. So hopefully, or let's say, unfortunately, in the next 3 months, we will have the 3rd wave as well. So the 2nd wave has been devastating. Every day in India, around 3,500 to 4,000 people are dying. The infection rate is close to 400,000 people. Every day, 400,000 people are getting infected. So that has been happening for the last 7 days. So it's incredible and it's really worrisome. So please stay safe. Don't go out unless it's absolutely necessary, and maintain all the protocols. With that, I wish you good health, stay safe, and bye. Before I hand over to Ankit for his vote of thanks. Ankit,
Yeah.
by the way, my son Peter lives in the same country where you live. He lives in the city of Magdeburg, which is close to Berlin, and he is a COVID survivor. He went back from India to Germany on the 12th of April, and on the 17th of April, he was detected COVID positive. So he just recovered and got his negative report a couple of days back. So please pray for him, please bless him so that he is healthy and he takes care of himself. Ankit, it's your turn to propose a vote of thanks.
Thank you. And yeah, I mean, thankfully my symptoms were not very serious, so it was all right. And I hope that it's not going to happen again, and not to me, not to anyone. So I would just like to wrap up today's discussion with a few closing remarks. Firstly, I would like to thank all the panelists for being here today, all the panelists who also stayed late past the schedule, and also to all the attendees for joining us today on Zoom as well as on our live broadcast on YouTube. My heartfelt gratitude to our sponsor, Veta Technologies, and a special thanks to the organizing committee led by Mr. Subrata Mitra, and to everyone from the Steel and Metallurgy team for making this event all previous events, and of course all upcoming events possible. It wouldn't be possible without the help of our organizing committee and the team, of course. So thank you all for joining us today. And with that, I would like to conclude today's meeting.
Thank you.
Thank you.
Stay safe. Take care.
Bye-bye.
Take care.
Bye.
Thank you. Bye.